So get this, Earth might be actually located near space highways that could connect us to other worlds. That's because our Sun sits right in the center of a giant bubble filled with hot gas, carved out by ancient supernovae. And this bubble likely has tunnels linking us to distant galaxies. So, does it mean it's time to develop space tourism? Well, let's figure it out. Most of us think space is just planets floating around in eternal darkness. But new research hints at the possibility that it might not be really true. It turns out our whole solar system is actually sitting inside a giant bubble of hot, thin gas. And it gets even better. Scientists now think there might even be a weird cosmic tunnel or channel made of this stuff. It supposedly stretches out toward faraway stars. Astronomers spent years mapping the sky, and after they put all the data together, they found something that looks like a long pathway of hot, low-density plasma, which is basically that very thin, superhot gas. And this so-called channel reaches out from around us to distant constellations. Researchers from Germany confirmed this discovery using data from a space telescope called eRosetta. We'll talk about it a tiny bit later. Now, interestingly, scientists discovered that our solar system sits inside something called the local hot bubble a long time ago. This bubble is actually a huge area, about 1,000 light-years wide. It was created when several stars exploded in giant supernovas millions of years ago. Those explosions heated up the gas around them and basically carved out this bubble of hot, low-density space. And their shock waves created weak points in the bubble around us, eventually forming interstellar tunnels. That cosmic event was so huge that the leftover hot plasma is still floating around us today. Now, to understand this bubble better, scientists used eRosetta, which is an X-ray telescope. It scans the sky looking for soft X-ray light. That's a kind of light we can't see with our eyes. It comes from hot gas, old supernova leftovers, and other structures in space. They also compared eRosetta's new information with older data from another X-ray telescope called ROSAT. And finally, putting all this information together, they were able to make a much clearer map of what's around our solar system. Mind you, this wasn't easy. They had to divide the sky into thousands of tiny pieces and carefully measure faint signals coming from warm gas, empty pockets of dust, and other stuff floating in space. But their effort paid off. After sorting through everything, they managed to figure out the faint glow of hot plasma around us. It proved we were not just drifting through empty space, we're inside a giant burned-out bubble created by extinguished stars. But what really surprised scientists was the discovery of some kind of channel. It looked like a long tunnel in space, cutting through the hot gas around us and connecting our part of the galaxy to star systems far away. They also found signs of another channel pointing toward the Canis Major constellation. And those might not be the only ones. The data suggests there could be a whole network of such paths, branching out through space. Each one works like a hidden back road. Scientists used to guess that the space around our solar system might have little pockets or rooms carved out by old exploding stars. We could probably imagine them like caves inside outer space, but no one had the necessary tools to actually prove it. But now, thanks to that new data from the eRosetta telescope, they finally have a clear picture. The telescope showed that the space around us wasn't just empty. It's full of hot, thin gas and strange shapes, including tunnels and bubbles. This proves at least part of what older scientists predicted. We're living inside a giant bubble of hot gas, and that bubble connects to other bubbles through long, low-density channels. The new study also shows that the pressure inside our bubble is lower than scientists expected. This might mean the bubble isn't closed. It could be open in some directions, letting that hot gas flow out into other parts of space. In short, this hot bubble isn't simple at all. Parts of it might be open pathways, and other parts look blocked off. Being inside it is kind of like trying to walk through a forest. Some areas have clear trails, and others are packed with trees. And even though astronomers have mapped big chunks of the bubble and found these strange channels, there's still a lot they don't fully get. Some paths look like they're made of a bunch of connected empty pockets, and others look totally closed. To understand the whole picture, we'll need better tools and more data. Hopefully, with stronger X-ray telescopes, deeper sky scans, and better computer models, we'll finally understand the nature and structure of the bubble we're living in. We might be able to make a kind of map of those hidden channels and learn how they affect things like cosmic rays, dust, and the solar wind around us. Now, speaking of telescopes, we can't help but mention the one that helped us figure out the very existence of the bubble around us. The thing is, scientists have been trying to understand a faint glow of low-energy X-rays that seem to cover the whole sky. For many years, they weren't sure where this glow was coming from. And then, the NASA-supported DXL mission finally helped to solve the mystery. Researchers used old but reliable detectors that first flew on a rocket in the 1970s. With these instruments, they confirmed that most of this X-ray glow came from a huge area of extremely hot gas around us. It was named the local hot bubble. Back in the 1990s, another X-ray mission called ROSAT made pretty good maps of the sky, and it found something surprising. Comets gave off soft X-rays too. Later, scientists realized this happened when the solar wind, fast particles from the sun, collided with neutral atoms. This process, called charge exchange, can happen almost anywhere in space. Because of this, some scientists started to doubt whether the local hot bubble was really the main source of the X-ray glow. So, to test this, DXL launched on December 12, 2012 from New Mexico. The rocket flew high above Earth's atmosphere for about 5 minutes, giving the instruments a clear view of space. The goal was to look at a worst-case situation where lots of charge exchange might occur. Right now, our solar system is moving through a cloud of cold gas in space, known as the local interstellar cloud. That's also nicknamed the local fluff. Cute, right? Neutral hydrogen and helium atoms from this cloud move through our solar system at very high speeds. Hydrogen gets affected easily by different forces, but helium mostly follows the pull of the sun's gravity. Because of this, the helium forms a focusing cone, a region with extra helium that Earth passes through every December. This cone is the perfect place to look for charge exchange, since it holds more neutral atoms than usual. But what happens during charge exchange? The solar wind comes from the sun's corona, the star's superhot outer layer. The particles in the solar wind have lost many of their electrons. When one of these particles hits a neutral atom, it can steal one of the atom's electrons. The stolen electron briefly gives off a soft X-ray. This is how the glow is created. Now, to compare things, the researchers also looked at old ROSAT data from 1990, taken in a direction away from the helium cone, where charge exchange should be weak. By putting everything together, the scientists found that only about 40% of the soft X-rays come from inside our solar system. The rest, the majority, comes from the local hot bubble. This means the huge cloud of hot gas around us really is the main source of the X-ray glow. But let's get back to the discovery of the Space Intergalactic Tunnel. It's a valuable lesson for us that space might look calm and empty when we look up, but that's not true. Space around us actually contains dust, plasma, radiation, magnetic fields, and mysterious tunnels. All of these things mix and swirl together, making space much more complicated than a simple vacuum.
Welcome aboard the most innovative, powerful, and safe spacecraft, Crysales, which will take you to exoplanet Proxima Centauri b of the Alpha Centauri star system. Thousands of brilliant minds have been working for decades to provide you with a comfortable journey through the depths of boundless space. You won't live to reach your destination, as the entire way takes more than 400 years. But rest assured, your descendants will reach Proxima Centauri b completely healthy. Now let me give you a tour of the ship and show you how it works. To ensure that living conditions on Crysales are as close as possible to those on Earth, scientists equip the ship with artificial gravity support. Thanks to the rotating hulls, you'll be able to walk here as if you're on your home planet. And the ship's length? A whopping 36 miles. Will definitely ensure you take long walks. You can sit on a bench in the park where botanists have planted flowers and trees grown on board. You can visit a library or have lunch at a cafe. You can meet your friends in the evening, or you can spend time at home watching documentaries about wildlife. Maintaining an earthly standard of living on the ship is possible thanks to the operation of thermonuclear reactors and the unique design of Crysales. The whole ship is built like a nesting doll. Several layers of the ship cover one another and spin around the central core. Each layer is equipped with a fusion reactor and public spaces, farms, warehouses, natural parks, technical departments, and many other facilities. The center of the ship has communication equipment and shuttles that will take you to Proxima Centauri b after Crysales approaches the upper layers of the planet's atmosphere. Factories for the production of food, plants, mushrooms, insects, microbes, and livestock are located on the level closest to the core. Earth's biodiversity is traveling with you to the neighboring star system. In order to maintain this biodiversity in natural conditions, engineers have equipped the ship with tropical and boreal forests. Scientists recommend regular visits to these natural areas to reduce anxiety and homesickness. The second level is designed to support passengers' social life. There are parks, schools, libraries, and hospitals here. Community and spending time together should protect you from existential horror and distract you from realizing how far away you are from your home planet. The next level of Crysales has an air and heat circulation center. If the core is the heart of the ship, then this area is its lungs. Then there's a layer designed for waste recycling, construction, and numerous factories. There will always be something to do on the ship, and you will never be out of work. This means you will never face a financial crisis. The last and furthest level from the core works as a giant warehouse for storing various resources, materials, equipment, and machines. In order not to burden people with additional work at this layer, engineers placed robots with artificial intelligence here. The ship's complex and multi-layered systems work to provide the passengers with the feeling that they're on Earth. But if you want to remind yourself where you really are, you can go to the front part of Crysales, where engineers installed a so-called space dome with a gravity zone. Here you will have a great time with zero gravity, enjoying an incredible panoramic view of space. In order to maintain a stable demographic and not provoke overpopulation of the ship, it's necessary to have at least 1,500 people on board. That's 900 people fewer than the stated capacity. Engineers and pilots responsible for managing the spacecraft will be cooperating with artificial intelligence. But of course, no comfort makes sense without security. The Crysales body has a cylindrical shape with a narrow front, which reduces the risk of impacts from small meteorites and space debris. Mobility, speed, and long flight time are provided by an engine working on a nuclear fusion isotope of helium and deuterium. It gives the ship a simultaneous boost of thrust and electrical power. Now, all your attention should be focused on the preservation of the human species. Over the course of 400 years, while the ship travels to its destination, several generations will change. Your kids and future descendants won't get the experience of living on Earth. Skilled teachers, engineers, and other professionals, along with artificial intelligence, will teach the next generation science, culture, and all the necessary knowledge that will help build our civilization in a new home. The success of the mission also depends on the psychological state of the passengers. For this reason, not everyone will be able to access the Crysales board. To adapt the human brain to the conditions of terrestrial isolation, The first generations will need to spend approximately 70 to 80 years in a remote area of Antarctica. Obviously, after such a long period, many won't be alive anymore, but they will make their descendants ready for a space mission. The first generation will never see space and will spend their entire lives in the cold Antarctica. What kind of person can be prepared for this? Their renunciation of the world and sacrifice for the sake of other people will set an example of the highest manifestation of love. This fact adds more responsibility to your mission. You've just watched the presentation of the Crysales project, which won first place at the Project Hyperion Design competition. A group of specialists has prepared a well-thought-out plan to create a spacecraft capable of taking us to the nearest planet suitable for habitation. According to estimates, this ship can be built in 20 to 25 years. But first, people need to invent fusion reactors. This project is a practical instruction on how to start the expansion of space, or how it can work like Plan B in case a global catastrophe happens on our planet. But what is this planet that has captured the minds of scientists and astronomers? Could it potentially become our new home? Proxima Centauri b is located 4.24 light-years away. It's not easy for the human mind to imagine and realize this distance, but relative to the entire outer space, it's very close to Earth. 1 light-year is the distance that you travel during 1 year moving at the speed of light, which is approximately 983 billion feet per second. The distance Crysales would have to cover is about 25 trillion miles. And the time needed for this journey is about 400 years. The ship would accelerate during the first year of this long voyage, and it'd slow down for the last year of the trip. It'd be a long, risky, and very exciting journey, but the result would be worth it. Proxima Centauri b was discovered in 2016. Its mass is 1.1 times that of Earth, and it orbits its star every 11 days. The distance between the planet and its star is ideal for getting enough light and maintaining temperatures above the freezing point of water. But because of this proximity, there is a possibility that Proxima Centauri b is under a strong influence of gravity and orbits the star with one side, like the Moon orbits Earth. Anyway, the planet immediately attracted everyone's attention because it turned out to be very similar to Earth in many ways. Scientists used special computer models to study Proxima Centauri b. The same models are used to study the climate of our planet. They found out there might be huge areas of liquid water in that distant world, and probably living organisms. But if the planet is always facing the sun with one side, there's probably a huge temperature imbalance. Fortunately, this problem can be solved. According to new calculations, Proxima Centauri b might have a large circulating ocean that can effectively transfer heat from one side of the exoplanet to the other. A similar process happens on Earth. For example, the east coast of the United States has a milder and warmer climate because the Gulf Stream carries warm water from the tropics there. In California, the ocean current brings cold waters from the north and prevents this side from getting too hot. So maybe Proxima Centauri b is really not a bad option for us.
Whoa, a wall of fire spreads around the epicenter of the impact. It burns everything in its path. The waves raised by the explosion cover large cities, and earthquakes are so strong that giant skyscrapers fall like a house of cards. So, these are the possible consequences of the collision with the first interstellar object in history to visit our solar system. We discovered it in 2017, but we're still not sure what it is: an asteroid, a comet, or a spaceship of some outer space civilization. So far, scientists have named it Oumuamua. Sounds like a Hawaiian cow. Well, whatever it is, its speed is much faster than other asteroids, about 54 miles per second. At that speed, you could cross the US from coast to coast in less than 3 minutes. So this asteroid could travel from Earth to the Sun in about 2 months. By comparison, our rockets can travel up to 17,000 miles per hour. The same trip across the United States would take them about 9 minutes. So many scientists speculate that this is an artificial object created by a very advanced civilization. Okay. The shape of the object supports this theory. It's long and narrow and resembles a spaceship. It's about half a mile long, way bigger than the Eiffel Tower. Scientists decided to see if Oumuamua was really someone's spaceship and pointed some radio telescopes at it. If the civilization on that ship had used communication or scanned us with their tech, we would have known about it. But there was complete silence. Kinda like that. Not a single radio wave. But that doesn't disprove the theory of outer space civilization. To find out for sure, we decided to determine the weight of the object. To do that, we use light. More precisely, its reflection. You see, different materials reflect light differently. We take an unknown black stone, for example. It absorbs almost all the light, reflecting almost nothing. Check out the catalog, it's charcoal. Knowing the size and material of the object, we can determine its weight. So, we need to see how much light this object reflects. And when scientists pointed their telescopes at Oumuamua, they learned that it reflects colors that match with iron and also with some solid rocks. And Oumuamua was flashing all the time, a bright flash. Then it would slowly fade, and then it would start to shine again. This means it was spinning. And it wasn't going around its axis like an arrow. It rotated chaotically, moving its edges up and down. Any artificial object or spacecraft would have been torn apart by such overloads. But Oumuamua is still intact. That means it's made of super hard materials that keep it from falling apart. And it's not hollow like a spaceship. It's one solid body. Hey, like me. The astounding speed of this object makes it pretty mysterious. Some comets can have the same or even higher speed, but they also have a kind of rocket effect. So when a spaceship starts from the launch pad, you see fire bursting out of its engines. Every second, the rocket mixes fuel with oxygen, ignites them, and ejects them at a tremendous speed. According to the laws of physics, this is like pushing off a wall. The rocket sort of jumps up from the combustion gases it throws down. That's how the rocket creates thrust and accelerates. Comets work on a similar principle. The sun's rays hit the surface of the comet. Light elements like ice start to evaporate. That gas goes one way, the comet goes the other. Just like a rocket, the comet is pushing off the evaporating gas and accelerates. This gas also forms the comet's long tail. It's as if the massive rock is dragging all this gas behind it. I can relate. Or it's like a car pulls air with it when it goes at high speed. But Oumuamua is not a comet, and it doesn't have that tail, and it doesn't have the same rocket effect as a comet. So it couldn't have accelerated to that speed. But some scientists believe that Oumuamua used to have a tail. Although we discovered it in 2017, it entered our solar system in 1995, and it was hit by the sun's rays even back then. When we discovered this asteroid, it had already lost about 95% of its mass. It simply evaporated. Other scientists believe that Oumuamua got this velocity during its birth, somewhere far away in another star system or nebula. Perhaps it was a dramatic collision of some exoplanet with another cosmic object. The colossal explosive energy of the collision threw the elongated shard into outer space. Or it could have been a supernova explosion. When a star reaches the end of its lifespan, it becomes a red giant. It's an inflated version of the star, hundreds of times bigger. Then it shrinks and explodes with tremendous force. The blast waves can travel many light years away from the epicenter, and it's one of the brightest events in the universe. So the supernova might have torn some exoplanet to pieces. One of them, Oumuamua, gained a lot of energy and speed and began its long journey toward Earth. This might explain why Oumuamua keeps spinning so wildly. But recently, scientists published a theory that Oumuamua may be a giant block of ice. The kind of ice we're used to is water, H2O, but Oumuamua could be nitrogen ice, N2. It may have remained intact in interstellar space for 500 million years. And when it arrived in our solar system, nitrogen ice could have reflected 2/3 of the sun's rays, so it didn't heat up as much. That explains why Oumuamua doesn't have a tail. You can find the same nitrogen ice on Pluto, as well as on Triton, one of Neptune's moons. So, Oumuamua comes from a similar icy exoplanet. But we can find out for sure only by sending a space probe to it. Scientists came up with a plan for that called Project Lyra. The problem is that Oumuamua is leaving our solar system at tremendous speeds, much faster than our rockets can fly. And we need to catch up with this space rock as quickly as possible before it gets too far away. To do this, we can use a gravity maneuver. First, the space probe makes a flyby of Jupiter. It passes close to it to take advantage of its gravity to accelerate. After that, the probe will head towards the Sun, and it'll fly around it as close as possible to fire like a catapult towards the space rock. The second option for reaching the asteroid is to use microprobes. We have to launch about 1,000 of them into orbit. They should be no heavier than a match. Each of them will have a light sail the size of a boxing ring. Then we'll focus a powerful laser beam from the ground onto this sail. It will allow us to accelerate the probe to about 20% of the speed of light. It shouldn't go too fast not to fly past the asteroid. It should be able to enter its orbit or land on it. But if we're too slow, Oumuamua will leave our solar system before we can catch up with it. It'll be a great experience because in the future, we'll be able to use such asteroids as a space taxi. All we have to do is enter the orbit of such an interstellar asteroid or even land on it. Then we would keep moving through space at incredible speeds without using any fuel at all. This would be a great option for traveling long distances or to deliver supplies to other star systems. So why should we be afraid of such objects? Well, a collision with an asteroid the size of Oumuamua could wipe out an entire state. If it were to hit somewhere in the ocean, it could cause waves taller than our skyscrapers. Scientists are anxious to find ways to protect us against such objects. One of them is ramming. If we spot a potentially hazardous object, we could send a spaceship towards it, pedal to the metal. The spacecraft will have to ram the asteroid at an angle that will move its trajectory just a little bit. Moving it too much on a cosmic scale would only dramatically change the asteroid's final destination, and we only need to get the asteroid past our planet. We can also create a controlled explosion on the asteroid. It's based on the same principle. The force of the explosion would have to shift the trajectory of the asteroid slightly, or smash a giant rock into smaller pieces. Asteroids up to 80 feet wide would burn up completely in our atmosphere due to friction against the air. Rocks between 80 feet and half a mile in size may not burn up completely and cause local damage. Anything larger is considered very hazardous. You think? The traditional method of science fiction is to put rocket engines on the asteroid. Then we can not only change the trajectory of the space rock, but also control it. And we can use it against other asteroids. It would be something like space billiards.
We probably won't be able to travel between stars if we play fair. And by playing fair, I mean following the laws of physics the way we currently see them. Playing unfair means using cheat codes. The big question is, do those cheat codes actually exist? Well, sorta. One of them is called a warp drive, a technology capable of interstellar travel. But how does it work? Let's find out. The first thing we need to understand is why a really fast spaceship isn't enough. Why can't we just build the ultimate engine, point the ship at another star, and go? The answer is distance. Space is too big. Right now, the fastest object ever created by humans is NASA's Parker Solar Probe. It was designed to fly extremely close to the Sun to study it. This probe uses gravity from Venus combined with continuous acceleration through the vacuum of space, which helped Parker reach a speed of about 430 miles per hour. But Parker is tiny, pilotless, and doesn't have to arrive anywhere. It just collects data and sends it back to Earth. And even at that speed, it's completely useless for interstellar travel. Compared to the speed of light, Parker is so slow that it's basically standing still. Light travels at about 669 million miles per hour. Now let's talk about the nearest star. Proxima Centauri is the closest star to our solar system, and it's about 4.2 light-years away in the constellation Centaurus. That means that even if we could somehow travel at the speed of light, it would still take more than 4 years to get there. Unfortunately, it's impossible. But why can't we go that fast? Why can't we reach Proxima Centauri in a year or even a month? The problem isn't engineering, it's energy. Any object with mass requires energy to accelerate. Think of a car. A 200 horsepower engine has a speed limit. If you want to go faster, you need more horsepower, more fuel, more energy. Physics lets us calculate exactly how much energy an object needs to reach high speed, factoring in mass, resistance, and distance. And here's the key point. As speed increases, energy requirements increase too. But when you approach the speed of light, the math stops behaving normally. The equations tell us that to actually reach light speed, you would need infinite energy, and this amount simply doesn't exist. That's why anything with mass can never reach or exceed the speed of light. If we play fair, interstellar travel is basically impossible. Yes, in theory, we could build a gigantic ship and send it drifting through space for tens of thousands of years, but that's dangerous, expensive, and wildly impractical. Which is why physicists started looking for cheat codes. One of those is the warp drive. It doesn't move a ship through space faster than light. Instead, it moves space itself. The idea was first proposed in 1994 by physicist Miguel Alcubierre. His solution showed that mathematically, we could distort spacetime in a very specific way by creating a bubble around a spacecraft. Spacetime in front of the ship contracts, spacetime behind it expands, and the ship sits calmly in the middle. From the ship's perspective, it's not moving faster than light at all, but from the outside, the bubble crosses enormous distances in very little time. If that sounds confusing, think about pulling a tablecloth off a table. If you do it fast enough, the dishes on the table don't move. So the dishes are the spaceship. The tablecloth is space-time. The table is a spot in another galaxy we want to get to. The ship doesn't slide across space. Space slides under the ship. Or imagine standing still on a moving escalator. Suddenly you jump and hold onto a crossbar on the ceiling. The escalator is moving under your feet when you jump off and land on a different step. The step that was far away from you before your jump. The escalator space was moving while you were holding the crossbar. So, the warp drive works on the same idea. Inside the bubble, passengers wouldn't feel extreme acceleration. Outside the bubble, space-time itself would be distorted. Sounds good, but there's a problem. The negative energy. Negative energy isn't just less energy. It's energy that behaves oppositely to normal energy. To understand it, we need to talk about something called the Casimir effect. You have two metal plates facing each other in a vacuum. They aren't charged, but they are conductive. There's no visible force acting on them, and yet a negative force pulls the plates toward one another. What does that mean? The plates are in a vacuum. Nothing is pushing them together. There's no classical energy involved. The plates are completely inert, but between them, quantum fluctuations create pressure that slowly forces the plates closer together. Let's not dive too deep into quantum physics and melt our brains. The important thing to understand is this: the pressure acting on the plates is not created by ordinary energy, but by negative energy. And more than that, it acts on space itself. Once again, normal energy makes objects move through a vacuum. Negative energy makes the vacuum itself compress. The Casimir effect proves that negative energy exists, but only in microscopic amounts. We can measure it, but we can't store it, scale it up, or control it in any useful way. For a warp drive, we would need unimaginable quantities of negative energy, enough to compress and stretch space-time around an entire spaceship. And right now, we have no idea how to generate that much negative energy, or whether it's even possible. That's why the warp drive working on negative energy is impossible. But why have scientists recently said interstellar travel might happen? because scientists proposed a warp drive model that doesn't require negative energy at all. Using extremely complex mathematics, researchers showed that it might be possible to create a warp-like effect using only ordinary, positive energy and the usual laws of physics. Here's a simple analogy. Imagine you need to lift a house using a crane that weighs 1 billion tons. That's the classic warp drive with negative energy. Theoretically possible, but completely unrealistic. The new idea is more like shifting the house using an incredibly complex system of pulleys, supports, and leverage, instead of the billion-ton crane. This new warp drive concept exists only on paper. The technology required to control space-time with that level of precision is far beyond anything we can currently build. It may take decades, it may take centuries, or it may turn out to be impractical after all. At the moment, the most realistic way to travel between stars is to board a massive spacecraft powered by a thermonuclear engine, capable of accelerating to incredible speeds. Yes, the journey would take a very long time, hundreds of years, but by then, human lifespans may be much longer. On top of that, we could use cryogenic capsules. You get on the ship, fall asleep in a pod, and wake up thousands of years later in another star system. It's possible that during that time, scientists back on Earth have invented a warp drive or some entirely new technology. Even so, this approach is still extremely dangerous. What happens during the journey? What if the ship breaks down or the destination planet turns out to be uninhabitable? Of course, all of these risks would have to be carefully calculated in advance. Another way of such travel you've probably seen in the Interstellar movie. Remember how the characters flew to another galaxy? They entered a wormhole, a tunnel connecting 2 points on opposite sides of the universe. Waiting around and hoping that a wormhole will just appear somewhere isn't exactly a great plan. Trying to invent such a tunnel ourselves? Maybe. In a few hundred years, technologies like that might exist. In any case, all this will not come home soon. But for now, let's enjoy traveling not between the stars, but between cities, countries, and continents. Fortunately, we have reliable technologies for such trips. These two sky photos were taken less than an hour apart. Play Spot the Difference and you'll notice that some bright dots disappeared. Before you think, oh, stars do that sometimes. Spoiler, they don't. This looks more like a human-made spacecraft passing through the shot. But here's the twist. The photos were taken in 1952, and that's 5 years before we even launched our first object into space. So, what are those dots? Could they be signs of artificial objects made by extraterrestrials? Well, yes, they could. At least that's one of the hypotheses proposed by researcher Beatriz Villarroel at Stockholm University in Sweden. She recently published 2 papers trying to explain these disappearing points of light in photos from the early 1950s, what her team calls transients. So, these are star-like objects of unknown origin that showed up in the first Palomar Observatory sky survey. This was a major astronomy project in California that used a nearly 50-inch telescope that produced almost 2,000 photographic plates of the northern night sky. And there's no denying it, the transients were there. And they were acting weird, disappearing all of a sudden. So scientists had to find an explanation, and that brings us to 4 big hypotheses about what they actually are. Hypothesis number 1. Stars. This is a cool theory because we can actually test it. Go outside tonight and look at the stars. Pay attention to where they are in the sky. Then check again tomorrow night. You might notice that a few stars seem to disappear. But they didn't vanish forever, they're just harder to see. They can get washed out by normal stuff like clouds, haze, humidity, or even bright moonlight. All of that can hide stars from your view for a while, but they'll show up again eventually. So could those transients from the 50s have been stars, and the survey just caught a moment where they seemed to disappear for a sec? You see, astronomers have plenty of things in the sky that look like they vanish. For example, variable stars, whose brightness goes up and down. You've also got supernovae, passing asteroids and active galaxies that can flare and fade. These changes can happen over minutes, days, or even years. But here's the problem. These transients don't really behave like that. In the old plates, they show up once, and then they're completely missing from images taken both before and after that. I mean, astronomers didn't see them on a blue-sensitive plate taken just 30 minutes earlier. They didn't show up on a red-sensitive plate taken 6 days later either. Whatever these things were, they were strange because there were so many of them, and they were gone so fast. One moment they're there, and then they never show up again. That's really odd. So no, they probably weren't stars. What seems more likely is that these flashes were sunlight reflecting off objects orbiting Earth. And that brings us to hypothesis number 2. They were satellites, or some other human-made spacecraft. You've got to remember, this was the 1950s, right when the space race was starting to take over headlines around the world. Everyone wanted to reach space, and they wanted to do it fast. So it's fair to ask, could this have been some kind of early satellite? And the answer is no. The Palomar survey plates were taken before the launch of the first artificial satellite, Sputnik, in 1957, so the timing doesn't really work, and that makes the human-made object theory pretty hard to support. Which brings us to hypothesis number 3. Extraterrestrial objects. Yep, something like an aircraft or a satellite, but made by a highly advanced civilization out there. Something that could have been flying around back then, maybe even watching us, and then for some reason never landed on Earth. It's a wild theory. But when you look at how strange these transients are, you can see why some people take this idea seriously. One thing I didn't tell you is that not all the bright dots were perfect little circles. Sometimes they showed up as straight lines or thin bands. Other times they looked sharp, almost star-shaped. And here's the weird part. Patterns like that can happen when light reflects off something with a flat surface. A regular space rock like an asteroid usually wouldn't have flat, manufactured-looking faces like that. So the study raises the possibility that something artificial might have been up there before humans even started launching spacecraft. And here's where it gets even stranger. These transients showed up around the same time as a bunch of old reports of strange objects in the sky. That same number in 1952, and a lot of people claimed they saw unusual flying objects over Washington, D.C. And it wasn't just 1 or 2 sightings. The U.S. Air Force recorded a total of 717 reports during that period. That's a pretty wild coincidence, but extraterrestrial tech might not be the final answer. Some scientists lean toward a 4th hypothesis: human experiments. These newer studies suggest there could be a link to things happening down on Earth. In fact, more than half of the transients showed up the day after nuclear tests. One idea is that the flashes could have been debris from those tests getting thrown high up into the atmosphere. But this theory isn't perfect either. The transients left streaks on the images during the 50-minute exposure. And for that to make sense, the debris would have to stick around and stay concentrated in roughly the same spot for about 24 hours to match what we see. That's really hard to believe, if not basically impossible. Out in space, something doesn't stay fixed over one location for a full day unless it's being actively controlled. So for now, scientists still need more evidence before this can be the main explanation. Well, it kind of feels like we're out of hypotheses, right? And now you see why these transients are still such a big mystery. But there's a group of scientists who think the explanation might be way simpler than it sounds. They think it could all come down to a bad photo. I know, that's not exactly thrilling, but hear me out. We're talking about old images from the 1950s. And you don't have to be an expert to know that back then, sky photos were nothing like what we can capture today. These images were recorded on photographic plates. Basically, they were glass plates coated with a light-sensitive layer, used long before digital cameras to capture the night sky. For their time, it was a big deal. It meant astronomers could store what they saw instead of drawing it by hand. But those plates had problems. They were sensitive, they could get damaged, and the images weren't nearly as clean as what we get with modern digital sensors. These plates can have issues like scratches and tiny defects in the light-sensitive coating. The digitizing process can also add things that weren't really supposed to be in the image. Suddenly, you're seeing a bright dot that could actually be, I don't know, saliva? It turns out humidity can leave marks on photographic plates too. And if a scientist sneezed near a plate at some point, for example, that could have left a weird trace in the image. So if someone handled them badly decades ago, that could leave odd traces in the image. And researchers point out that some of the faintest transients show up in areas of the plates that look contaminated. To completely rule out this hypothesis, they need to inspect the original plates under a microscope. The problem is, the researchers don't have access to the originals. They're working with digitized copies. Still, Villarroel isn't fully convinced it's all just image errors. She says some of these transients line up in ways that are just too unlikely to be random. So the idea now is to keep digging into this with a project called ExoProbe. The goal of the program is to build a network of telescopes that will scan the sky for quick, sudden flashes of light. And if these transients are real, we might not have to wait much longer to find out. Stop for a second and look at the ground beneath your feet. Is it a quiet suburban street, a flat basketball court, or maybe a peaceful stretch of farmland? You probably feel safe because there isn't a giant smoking mountain on the horizon, but that safety is an illusion. Yeah, sure. Yellowstone, Vesuvius, or Mount Fuji, those are the celebrities of the geological world. Giants that dominate the skyline and sometimes blow their tops. But what about a hidden threat? One that doesn't look like a volcano at all. It's invisible, it's silent, and thousands of these traps are scattered across the planet, lurking right under the foundations of our biggest cities. Scientists call them monogenetic volcanic fields. To the untrained eye, they don't look like volcanoes at all. They disguise themselves as innocent hills, flat plains, or just lovely lakes. For decades, they were mainly ignored because of their small size. But new data suggests these hidden systems are far more dangerous than previously thought. And unlike the big giants that give weeks of warning rumbles, these invisible volcanoes specialize in surprise attacks. Hold tight. To understand the danger, we have to look at the plumbing. A standard volcano acts like a simple chimney. There is a central magma chamber and a main pipe leading to the surface. Eruption after eruption, lava flows out the same vent, building a massive cone over thousands of years. Monogenetic fields break all these rules. They don't build mountains. They don't reuse the same pipe. Instead of a chimney, imagine a cracked windshield. Magma deep underground scans for any weakness in the crust over a massive area. It pushes up, cracks the surface, erupts once, usually violently, and then calms down forever. The next time magma rises, it won't use that old vent. It will find a new crack 5 miles away, or 10. This means you can't just monitor one specific mountain. The entire region is a danger zone. And because each volcano is a one-and-done event, the landscape is deceptive. You could drive past a site of a violent ancient explosion every day on your way to work and simply see a grassy knoll. The scary part is the speed. In these fields, magma can rocket from 30 miles down to the surface in less than 24 hours. It moves at a speed of up to 4 miles per hour. That sounds slow for a car, but for melting rocks, that is the speed of an elevator. This isn't just a theoretical problem for empty deserts. Take Auckland, New Zealand. It's a stunning modern city with beautiful harbors and over 1 million residents. But Auckland is built directly on top of a geological minefield. Sounds a bit crazy, right? Beneath rugby stadiums, parks, and busy intersections lies the Auckland Volcanic Field. Those scenic green hills scattered across the city aren't just landscaping. They're the remains of over 53 separate volcanic eruptions. Rangitoto Island, which sits just offshore, emerged from the ocean only 600 years ago. In geological time, that was 5 minutes ago. For years, this field was considered sleepy, but recently, scientists have started noticing subtle changes. The terrifying reality of a field like this isn't that a volcano we already know will erupt again. It's that a new one can pop up and go from zero to a disaster in the blink of an eye. A bubble of magma could rise silently beneath a factory, a highway interchange, or a residential neighborhood. There is no designated safe zone because the threat is spread across the entire city map. History gives us a brutal example of how fast this happens. In 1943, a farmer named Dionisio Pulido was plowing his cornfield in Mexico, on the outskirts of Mexico City. It was a normal Tuesday. Suddenly, the ground cracked open right in front of him. Smoke hissed out, smelling of rotten eggs. Within 24 hours, that small crack in a flat field had transformed into a raging volcano 160 feet tall. Within a week, it stood 500 feet high. This was the birth of Paricutin. It wiped out 2 entire towns, leaving only the stone steeple of a church poking out of the hardened lava, a haunting monument that still stands today. This geological nightmare started in a simple cornfield, and it wasn't an isolated incident. Look at the Harat Rahat field in Saudi Arabia. In 1256, a massive fissure opened up near the city of Medina. It spewed lava for 52 days, creating a river of fire 14 miles long. Today, that same volcanic field is still there, and modern Medina has expanded right on top of the ancient lava flows. Now, apply that same story to a suburb of Los Angeles, a district in Tokyo, or a neighborhood in Europe. In a matter of days, an entire city can be buried under ash. The risk is global, ranging from over 1,800 vents in the American Southwest to the restless Eifel region in Germany and similar fields in China. Experts warn that the real risk here isn't size, but frequency and location. These volcanoes tend to be explosive. When magma rises rapidly and hits groundwater, which is common under cities and fertile farmland, it flashes into steam. This creates a phreatomagnetic explosion. Instead of a slow, oozing river of lava that people can walk away from, the ground acts like a shotgun blast. It sends a massive column of ash and rock shooting into the atmosphere. In our modern world, this is a recipe for chaos. We rely on delicate systems, air travel, GPS signals, just-in-time supply chains. You don't need a supervolcano to crash the global economy. A small eruption near a major logistics hub is enough. Remember the 2010 eruption in Iceland? That wasn't even a big explosion by historical standards. Yet, the ash cloud grounded over 100,000 flights, and 10 million passengers were stranded. Volcanic ash melts inside jet engines, while toxic dust poisons crops and contaminates water reservoirs with heavy metals. It creates a domino effect. One small eruption in the wrong place triggers a cascading failure of global infrastructure. And the most alarming part is that the signals are already there. Recent geological studies have shown an uptick in activity in these distributed fields. It isn't always violent earthquakes. Often, it's bradyseism, the slow rhythmic breathing of the ground. We mentioned the Eifel region of Germany, where GPS data shows the land is rising by about 0.04 inches per year. It sounds tiny, but for geologists, that is a proper red flag. Scientists are detecting slight swells in the Earth's crust and weird spikes in carbon dioxide emissions in places that should be quiet. Magma is moving, but because these systems are so spread out, monitoring them is a nightmare. We have sensors all over Yellowstone. We watch Vesuvius 24/7, but almost no one is watching a random patch of desert in Arizona or a forest floor in Germany. These invisible volcanoes are poorly studied. We lack the baseline data to know if a tremor is just a truck driving by or the start of a Paricutin-style event. This lack of data means that when an eruption starts, authorities might have almost zero warning. In a polygenetic volcano, the mountain swells for months. In a monogenetic field, magma can shoot from the deep mantle to the surface in hours. By the time the evacuation order is written, the lava could already be breaking through the pavement. It isn't that hard to imagine the logistical nightmare. A city not known for volcanoes suddenly receives an alert. A vent is forming downtown. It sounds impossible. People delay leaving. They grab their phones to film the smoke. Then, explosions start. The ash creates a blackout. Power grids fail as wet ash shorts out transformers. Roads gridlock instantly. This scenario isn't science fiction. It's exactly what hazard models predict for places like the Auckland Volcanic Field or parts of the Trans-Mexican Volcanic Belt. We are building denser and denser cities on top of geological landmines. This doesn't mean we need to start digging bunkers, but it does require a shift in perspective. We have spent so much time worrying about the celebrity volcanoes that we forgot about the quiet ones. The Earth is a living, shifting engine that doesn't care about property lines or city limits. Scientists are now pushing for better monitoring networks, using satellites to track even the tiniest ground deformation in these boring, flat fields. Because the only way to survive a surprise attack is to see it coming before the ground cracks open. Peace and quiet on the surface doesn't always mean peace and quiet underneath. The Earth has plenty of secrets left, and some of them are just waiting for the right moment to surface. It's 3 a.m. Suddenly, a radio telescope beeps. The monitor shows a violent, massive burst of energy where it shouldn't be. The scientist spills his coffee, scrambles to hit record, and zooms in on the source, but finds nothing. Just silence. Was this a glitch or some cosmic coincidence? Actually, new research argues that this is exactly what first contact might look like. Science fiction has been preparing us for meeting ETs for decades. Since we can't travel through space yet, we kind of hope they'll come to us. Hopefully in peace without the laser weapons. But astronomers shrug and say this is highly unlikely. So they've built better telescopes and asked a better question. If life exists out there, what would actually jump out on our screens? That brings us to the streetlight effect. It's the simple idea of searching for your lost keys under the lamppost, just because that's where it's easiest to see. Scientists do the same thing with the universe. They catch the stuff that's easiest to detect, not what's most common. This is how the first planets outside our solar system were discovered in 1992. For years, astronomers stared at sun-like stars, hunting for Earth-like planets, and found nothing. Instead, the first exoplanets showed up orbiting a pulsar. When a giant star runs out of fuel, its core gets squeezed into an incredibly dense chunk of matter that spins unbelievably fast. When rotating, it can aim a radio beam our way like a space lighthouse. Every time the beam crosses Earth, we detect it like a pulse. Thump, thump, thump. That's why it got the name pulsar. Turns out it was just spinning, but we kept the name. The timing of pulses stays so precise that it works like a cosmic stopwatch. So when a nearby planet tugs on a pulsar, that perfect timing wobbles. The pulses might arrive a bit too early or a bit too late. That's how astronomers found the surrounding planets. That's the streetlight effect on a cosmic scale. The idea is that we will only notice intelligent life if it does something loud that sets off alarms or breaks some rules. A Columbia astrophysicist named David Kipping gave the idea a name, the eschaton hypothesis. Eschaton comes from Greek and points to the end, like the final chapter. The idea is that when we finally find signs of intelligent life out there, it probably won't be during peaceful times. It will be because something went wrong. Some one-of-a-kind situation for them. A moment so loud it rips through the background static of the universe and reaches all the way over here. Calm civilizations don't show up on radar. A world that runs on clean energy and keeps its tech quiet could last 1,000,000 years, and we'd never know it was there. But what if they did something big and messy just to survive? Maybe they fired up a planet-wide laser array to nudge an incoming asteroid off course. Or maybe they're testing some super advanced technology. Whatever the noise, even if it lasts for just a few seconds, it could hit radio dishes across the galaxy like a flare. Yes, all of that sounds like science fiction, but that's exactly why we'd notice it. But here's an interesting question. Have we already detected such a signal? There is one candidate that fits this profile perfectly. It remains the most famous unsolved mystery in the history of the search for extraterrestrial intelligence. In 1977, Ohio's Big Ear Telescope caught a radio surge about 30 times stronger than the background, and a volunteer spotted it in the printout. He highlighted the signal's intensity reading, 6EQUJ5, and scribbled down "Wow" next to it, which is how the event got its popular name. The signal lasted exactly 72 seconds. This duration is significant because it matched the time it took for the Earth's rotation to scan across that specific point in the sky. The signal didn't fade away. The telescope simply looked past it. However, when astronomers returned to that spot, nothing was there. They've listened for nearly 50 years, but the signal never repeated. In the science world, things that can't be repeated usually get tossed aside as mistakes. It's important to be careful because false alarms happen pretty often. There's a famous false alarm that still makes astronomers cringe. At the Parkes Observatory in Australia, telescopes kept picking up weird, chirpy signals starting in the late 90s. For 17 years, nobody could figure them out. People blamed lightning, space weather, and space invaders. But in 2015, they all figured it out. The strange signal was coming from the microwave in the break room. If a hungry scientist pulled the door open before the timer hit 0, it leaked a tiny burst of radio waves that looked exactly like a signal from deep space. 17 years of mystery for a disappointing reveal. But the WOW signal didn't behave like that. It didn't look like a satellite, a plane, or any kind of interference, and they definitely made sure it wasn't a kitchen appliance. It came from deep space, near the constellation of Sagittarius. If we apply Kipping's eschaton theory, this might be what we need to prove life outside our planet. The WOW signal could have been an engine flare from a colony ship trying to escape a disappearing world. Or it could have been a rare natural radio event that just happened to hit us at the perfect moment. The WOW signal grabbed attention because it reached us in radio waves. But Kipping's theory also asks, what if a civilization gives itself away in a completely different way, not with sound, but with pollution? Clues that technology, not nature, caused something are called techno-signatures. Think of them as leftover traces. If you walk into a house that smells of fresh paint, you can assume someone was there recently. Astronomers use the same logic with planets. They scan distant exoplanet atmospheres for chemicals that shouldn't exist naturally. The biggest target is a family of chemicals called CFCs. For decades, humans filled the air with these gases because they were cheap and useful. We used them in spray cans and cooling systems, until scientists realized they were bad for the ozone layer. That's why CFCs are such a big deal. Nature doesn't make them. These chemicals are 100% artificial. So if we point a telescope at a distant planet and find its air is full of CFCs, it would be the vital clue astronomers have been waiting for. It could mean someone intelligent is down there, and they're polluting their world on an industrial scale. Besides radio waves and chemistry, you might be able to spot a civilization if they're doing something cool with light. In 2015, astronomers watching a star about 1,400 light-years away, nicknamed Tabby Star, noticed something that seemed impossible. When a Jupiter-sized planet crosses a star, it blocks about 1% of the light. But this star suddenly dimmed by 22%, and it wasn't one clean dip either. The brightness kept plunging in weird, uneven chunks with no tidy, repeatable schedule. That's something huge getting in the way. For a brief moment, scientists hoped for a Dyson swarm. That's a hypothetical megastructure made of solar panels and wrapped around a star to capture its energy. Sadly, later studies leaned toward dust clouds instead, but Tabby's star still grabs attention. We keep asking, where is everybody? But for decades, we could only watch a tiny slice of the sky at a time. That's about to change with telescopes like the Rubin Observatory that will sweep the entire southern sky every few nights, over and over, like a giant security camera for the universe. If something flickers, flashes, or suddenly vanishes, we won't just get one blurry screenshot, we'll have the replay. Finally, what if we are the loud ones? We tend to think Earth is noisy because of our TV shows and music, but those signals fade fast. Our real scream is planetary radar. We blast massive radio beams into space to map asteroids. Some researchers estimate that these shouts could be detected from as far as 12,000 light-years away. That's very far, but in space terms, it isn't even the backyard. If we really want to get someone's attention, we need to get way louder. Tiny microbes, basically ancient germs, have been frozen in Arctic ice for tens of thousands of years, just chilling there, since woolly mammoths were still walking around. And now, scientists think these little guys might wake up again if Arctic summers keep getting longer and warmer. Yep, you heard right. Zombie microbes. Great. These microbes have been stuck in permafrost, which is soil and ice that stays frozen solid year-round. The top layer melts a bit in the summer, but the really old stuff, those Ice Age microbes, are buried way deeper. They only thaw if things get really warm for months, not just a hot day or two. To study these microbes, the team went down to the Permafrost Research Tunnel near Fairbanks in Alaska, a long underground hallway 50 feet below the surface, carved right into the ancient frozen ground. The tunnel stretches over 350 feet and lets scientists literally walk through thousands of years of frozen history. By the way, while checking out the walls, the researchers also spotted bones of mammoths and bison sticking out of the ice. One of the reasons why the researchers went to Alaska was to see how fast these ancient microbes could come back to life. Well, they were in for a surprise. These microbes don't need years, centuries, or magic spells to wake up. Just a couple of months of warm weather. Once they're awake, they start doing their microbe stuff, which includes pumping out greenhouse gases like CO2 and methane. And that's bad news, because those gases warm the planet even more. This melts more permafrost, which wakes up more microbes, which releases more gas. You get it. Basically, it's a nasty climate loop. Anyway, when scientists went down into the frozen tunnel to grab chunks of super old permafrost, the first thing they noticed was the awful smell. It wasn't just the stench of an old basement. It was something has been frozen for thousands of years and is finally waking up bad. Weirdly, microbiologists were happy. Such a smell is actually a good sign for them because it usually means tiny creatures, microbes, are still around. Back in the lab, the team soaked the frozen samples in the water that had a special kind of heavy hydrogen inside it. This helped them track what the microbes were doing later. Then they put the samples into fridges at 3 different temperatures: cold, kinda cold, and not too cold, to copy what future Arctic summers might feel like if the warming continues. For the first month, almost nothing happened. Even the warmer samples barely changed. Only a tiny number of microbes started waking up. Basically, a microscopic trickle of activity. But a few months later, things got more exciting. Thanks to the heavy water, scientists could watch how much of it the microbes used to build their cell membranes. It helped them figure out that the old microbes were making special fatty molecules that might help them stay alive in freezing conditions. By the 6-month mark, the samples that were stored at the warmer temperatures had transformed completely. They became more active and started forming little slime layers. The scientists could actually see these layers even without a microscope. The whole community of microbes wasn't super diverse, but those that were active behaved just like modern microbes that live in unfrozen soil today. In short, those ancient microbes were definitely alive and got pretty energetic once the temperatures were warm enough. This matters a lot for the Arctic and for the whole planet, because these microbes survive by eating old organic material trapped in the permafrost. When they eat, they release greenhouse gases like carbon dioxide and methane, and the Arctic is warming faster than any other part of Earth. It means that the deep frozen layers might stay warm long enough for huge numbers of ancient microbes to wake up and start pumping out gas. Right now, northern permafrost holds about twice as much carbon as the entire atmosphere. If a lot of that carbon gets released, it could speed up the warming of our planet. It can lead to dramatic consequences, setting off a whole chain of huge changes and affecting basically everything on Earth. Extreme weather will start happening more often. Stronger hurricanes, heavier rainstorms, longer heat waves, bigger wildfires. The oceans will rise too, which can flood coastlines and put towns and cities at risk. Animals, plants, and entire ecosystems can get thrown out of balance, with some species struggling to survive and food chains breaking down. People all over the world will have to deal with crop failures, water shortages, and damaged homes or infrastructure. Let's get back to our zombie microbes. The thing is, the study only looked at them in one place in Alaska, but there's a massive amount of permafrost all over the world, in Alaska, Canada, Siberia, and many other places. And microbes in different regions might behave differently as things warm up. Scientists still have tons of work to do to figure out what's coming next. I bet you're questioning yourself. Could ancient viruses infect us? Well, most of the ancient microbes frozen in permafrost are totally harmless. They're like old bacteria that only care about messing with other tiny organisms in the dirt. But scientists worry that a few of these frozen germs might be the kind that can infect people, animals, or plants. And if that happened, our bodies probably wouldn't recognize them at all, because they've been frozen since mammoths existed. Basically, there's no immune system cheat codes for us. The risks of this happening grow for a number of reasons. For one thing, the Arctic is warming almost 4 times faster than the rest of the planet. Longer summers plus hotter temperatures mean more permafrost melting. So, more ancient stuff is waking up. Plus, people might start digging more around there. Companies will mine more, drill for oil, and ships can travel new routes. All this activity tears open ground that used to stay frozen solid. This increases the chance that someone or something comes across some ancient germ that just woke up. What would actually happen then? We might run into different zoonotic diseases, basically germs that jump from animals to humans. This already happened once. Thawed reindeer carcasses released anthrax, a rare and serious illness which then infected people and animals. Luckily, we do know how to treat anthrax. But what if something even older wakes up? Besides, our immune system might have zero defense. If a virus hasn't been around for tens of thousands of years, humans today would be like, what is that thing? No antibodies, no memories of it, nothing. But the scariest part is that we don't know what's hiding down there. Scientists think permafrost might be storing trillions of frozen microbes, many of which we've never seen before. Some might be boring, and some might be super dangerous. So what if one such virus finally thawed out? The world would be dealing with a disaster no one has ever seen before. This wouldn't look like a normal outbreak. It would feel more like something out of a horror movie. First, the virus would be totally new and our immune systems definitely wouldn't recognize it. That means the virus would spread crazy fast, jumping from person to person. No one would know what to expect. It could cause weird illnesses, sudden fevers, or even something way more dangerous. Stuff as scary as the diseases people faced in old times. Scientists digging in permafrost already look for traces of those ancient diseases, so it's not impossible. Once it escapes, the virus wouldn't stay local for long, with people traveling everywhere and companies rushing into the warming Arctic for mining and shipping. The infection could go from one small Arctic village to major cities all over the world within days. Hospitals would fill up instantly and doctors and nurses would run out of supplies. Businesses would shut down. Food supplies could crash if the virus hit farm animals or crops. Shipping and travel could freeze completely. Fear and panic would spread around the globe almost as fast as the virus itself. There'd be no vaccine and no cure, because no one has ever seen this virus before. Scientists would have to start from zero. In short, a zombie virus outbreak would be totally unpredictable, and the modern world is certainly not ready for it. While you're watching this video, pieces of continents are slowly breaking off from below and are pulled down into the oceanic mantle. a hot, mostly solid layer that moves slowly under the seafloor. As soon as these fragments reach the mantle, they can trigger volcanic eruptions in parts of the ocean where there are no volcanoes. Plus, when continents break apart, it happens not only at the surface, but also deep down. But more on that later. This process can continue for tens of millions of years. The new study shows that Earth's insides are even more dynamic than we thought. It also explains why many volcanic islands, including Christmas Island in the Northeast Indian Ocean, contain unusually high levels of certain chemical elements. The thing is, these elements are normally only found in continental crust. Well, scientists did suspect that these elements showed up because some powerful forces deep inside the Earth took old, recycled pieces of rock and mixed them into the mantle. This process works a bit like when you mix together ingredients for cake batter. But before, researchers believed those elements came from two main sources: sediment that sank into the mantle as oceanic plates got pushed down, or from mantle plumes. Those are columns of hot rock rising up from deep inside Earth. However, these explanations don't fit all observations. In some volcanic areas, there's almost no sign that the crust has been recycled. In other places, the mantle seems to cool and too close to the surface to be affected by the rising hot rock. Scientists used to wonder how this could happen. Now we know that some of the material in those regions comes from pieces of continents that sink deep into the mantle, and these pieces affect the volcanoes that form above. The new study also suggests a curious idea. Continents don't just break apart at the surface, they peel away from below too. And this can happen over much greater distances than scientists thought before. Researchers used simulations to figure out how continents and the mantle behaved when stretched by tectonic forces. Their work is built on earlier research showing that when continents split, deep, powerful forces inside our planet create a mantle wave. This wave moves along the base of the continent at depths of about 90 to 125 miles. The wave moves extremely slowly, about a millionth of the speed of a snail, and gradually strips material from the roots of the continents. These peeled-off fragments are then carried sideways, sometimes more than 620 miles, into the oceanic mantle. Once there, they can trigger volcanic eruptions in the ocean for tens of millions of years. The research also shows that the mantle continues to feel effects of continental breakup long after the continents themselves have separated. Even after a new ocean basin forms, the mantle keeps moving, reorganizing and transporting enriched material far from where it originally came. To make this conclusion, researchers studied geochemical data from different parts of the Earth, including the Indian Ocean Seamount Province. That's a chain of volcanic formations that appeared after the supercontinent Gondwana had broken apart over 100 million years ago. Their computer models and chemical tests showed that right after the supercontinent Gondwana broke apart, a lot of magma with unusual chemicals pushed up to the surface. Over millions of years, this chemical signature slowly faded as less material came up from under the continent. The most unexpected discovery is that this happened without any help from those deep, hot columns of rock scientists used to think were needed. Now, to get an even clearer picture, let's sneak a peek into our planet's insides. Earth is about 4.6 billion years old. It was born from a huge cloud of dust and gas that slowly cooled, shrank, and hardened into the planet we know today. As it cooled, heavy metals like iron and nickel sank to the center, and lighter, rocky materials floated upward. This created the Earth's layered structure, with each layer having its own unique properties. The crust is like Earth's skin. It's our planet's outermost layer made of solid rock. It's broken into huge pieces called tectonic plates that slowly drift over time. There are two kinds of crust: oceanic crust and continental crust. The oceanic crust is about 4 to 6 miles thick. It's covered with a thin layer of sediments like sand, clay, and shells. Below that are dense rocks like basalt, rich in magnesium. As for the continental crust, it's thicker than oceanic crust and is located under continents. It's made of lighter rocks than oceanic crust. Beneath the crust is the mantle. It makes up more than 75% of Earth's volume. The top of the mantle is pretty rigid, but deeper down it becomes soft and partially molten, which allows it to flow slowly. This flow is what moves the tectonic plates. At the center of the Earth lies the core. It's made mostly of iron and nickel and has two distinct layers, the outer core and the inner core. The outer core is a liquid layer of iron and nickel. It's insanely hot, up to 10,800 degrees Fahrenheit, as hot as the surface of the sun. The outer core also generates Earth's magnetic field, which protects us from harmful solar radiation. The inner core is solid because of the crushing pressure inside the planet. It's also made of iron and nickel. Now, the Earth's outer shell, called the lithosphere, is made up of the crust and the uppermost part of the mantle. It's broken into large pieces, called tectonic plates. There are a few super large plates and many smaller ones. 6 of the major plates are named after the continents they carry, like the North American, African, and Antarctic plates. But even those smaller plates play an important role. For example, the tiny Juan de Fuca plate is responsible for many of the volcanoes in the Pacific Northwest of the United States. The plates are moving like a jumble of old conveyor belts. They move very slowly, about 1 to 2 inches per year. But over millions of years, this movement shapes the face of our planet. Most earthquakes, volcanoes, and mountain building happen where plates meet, pull apart, or slide past each other. There are 3 main types of plate boundaries: convergent, when plates move toward each other; divergent, when plates move apart; and transform. That's when plates slide sideways past each other. When tectonic plates collide, the crust crumples and buckles, forming mountain ranges. About 55 million years ago, India crashed into Asia, slowly creating the Himalayas, the tallest mountains on Earth. The collision continues today, so the mountains are still rising. Mount Everest, the highest point on Earth, may even grow a tiny bit taller over time. At some convergent boundaries, an oceanic plate dives under a land plate in a process called subduction. The land above lifts up, forming mountains, and the sinking plate melts and triggers volcanic eruptions. This is how some mountains in the Andes of South America were formed. When 2 oceanic plates collide, one usually slides beneath the other, creating deep ocean trenches, like the Mariana Trench in the North Pacific, the deepest point on Earth. These collisions can also form underwater volcanoes that eventually rise above the ocean and turn into island chains, such as Japan. At divergent boundaries, tectonic plates move away from each other. In the oceans, magma from deep in the mantle rises to fill the gap. This creates underwater mountains and volcanoes along the seam. This process renews the ocean floor and slowly widens the ocean basins. By the way, a single mid-ocean ridge system connects all the world's oceans, making it the longest mountain range on Earth. On land, when plates pull apart, they form giant valleys, such as the Great Rift Valley in Africa. If this stretching continues over millions of years, East Africa could split off to become a new landmass. One famous example of transform boundaries is the San Andreas Fault in California. Unlike convergent or divergent boundaries, transform boundaries usually don't create mountains or oceans, but the grinding motion can cause powerful earthquakes, such as the 1906 earthquake that destroyed much of San Francisco. Australia feels like the safest place on Earth, geologically speaking. No megavolcanoes, no massive fault lines slicing cities in half, no constant earthquake alerts. It looks solid and unbreakable, but according to a brand new global stress map of Earth's crust, Australia is one of the most internally stressed pieces of land on the entire planet. It's not shaking or cracking yet, but it's quietly storing energy like a bent ruler about to snap. To understand why this is such a big deal, imagine Earth's crust like a giant jigsaw puzzle made of moving slabs called tectonic plates. These plates float on softer rock below and push, pull, or grind against each other. Where plates meet, earthquakes and volcanoes make sense. But stress doesn't just stay at the edges, it travels. It builds up inside plates too, like pressure spreading through frozen ice when you squeeze it. Scientists mapped over 100,000 real stress measurements from oil wells, rock tests, and earthquakes to see where Earth is being squeezed the hardest right now. When they laid all the data together, the map lit up like a warning sign, and Australia stood out. This shocked scientists because Australia sits far away from plate boundaries, which usually means stability. But instead of relaxing, the Australian continent gets squeezed from multiple directions by nearby plates, especially the Pacific and Eurasian ones. The stress doesn't release easily, so it piles up inside the crust, and then nothing moves. Until suddenly everything does. One of the strangest discoveries showed up in places like the Bowen Basin, where stress directions twist and rotate underground. That's bad news because unpredictable stress behaves like glass about to shatter. These rotating stress fields make it nearly impossible to say when or where cracks could form. It could be years away or tomorrow. And human activity makes it even riskier. Drilling deep into the crust for geothermal energy or injecting fluids underground can nudge these stressed zones just enough to trigger fault movement. This doesn't mean Australia is about to split in half next week, but it does mean the idea of geologically safe might be outdated. Scientists now think Australia could eventually fracture internally and form new fault systems where none existed before. What makes the new stress map different from older models is that it doesn't just explain past earthquakes, it helps identify future risk zones before anything breaks. Countries can use this data to decide where drilling is safer, where tunnels shouldn't go, and where infrastructure needs reinforcement. But even with all this data, we still can't predict the exact moment Earth will snap. Stress maps tell us where the tension is. They don't tell us when it gives up. But this idea of continents quietly tearing themselves apart isn't just theory. Africa gives us the clearest real-world example. It's slowly unzipping itself. So slowly that no human will ever wake up and see a new ocean where land used to be, but fast enough that scientists can actually measure it happening right now. Deep beneath East Africa, the ground stretches, thins, and pulls apart as if the continent is taking a deep breath and never fully exhaling. And over millions of years, that stretch could turn into an ocean. This whole process centers on something called the East African Rift System, or EARS for short. Think of it like a giant tear running through the continent, thousands of miles long, cutting through countries like Ethiopia, Kenya, Tanzania, and Mozambique. It's one of the biggest rift zones on Earth. A rift zone is exactly what it sounds like, a place where the planet's crust is being pulled apart instead of squeezed together. And Africa just happens to have one of the most dramatic examples anywhere on the planet. What's really happening is that Africa isn't one solid plate anymore. It's splitting into two massive chunks, the Nubian plate to the west and the Somalian plate to the east. These two plates are drifting away from each other at a speed that sounds laughable, just less than an inch per year. That's about the speed your fingernails grow. But give that process millions of years and suddenly continents don't look so permanent anymore. In 2018, photos of a giant split in Kenya went viral across the internet. Headlines screamed that Africa was splitting in half right now. It looked dramatic, but that moment didn't mean Africa suddenly broke overnight. That rupture was more like a surface ripple, a small local sign of a much bigger process that's been going on for around 25 million years. And if we could travel in time to 5 or 10 million years from now, we would probably see the crust thin enough for seawater to rush in. When or if that happens, East Africa would slowly peel away from the rest of the continent, and a brand new ocean basin would form between the two plates. Africa would lose its eastern shoulder, and maps of the world would need a serious update. As strange as that sounds, it's actually totally normal for Earth. The planet never stops reshaping itself. It just works on a timeline so slow that our brains struggle to process it. The continents we know today feel ancient and permanent, but they're basically temporary arrangements. About 138 million years ago, South America and Africa were locked together like puzzle pieces. You can still see it if you look at their coastlines. They match almost perfectly. East Africa drifting away will just be the next chapter in that story. Australia's story could follow a different path, but the physics are similar. Stress builds, rock resists, then the rock fails. And stress doesn't care about borders, cities, or how calm the surface looks. That's why scientists are so concerned about something called SH max, the direction of maximum horizontal stress. In simple terms, it tells us which way the Earth is squeezing the hardest underground. If that squeezing lines up with existing fractures, earthquakes become more likely. If it cuts across old faults, new ones can form. Turkey is another place where the stress map practically screams danger. The country sits where Arabian, Eurasian, and African tectonic plates collide. There's also a smaller Anatolian plate on which Turkey is located, and which gets squeezed westward like toothpaste, grinding against massive faults. The stress map shows SH max pointing in directions that load these faults perfectly. Now, researchers looked at ancient lava flows near one of Turkey's faults and realized they weren't random. Lava sheets once flowed smoothly across the land, cooled into solid rock, and then got pulled apart over time, like a snapped chocolate bar. That gave scientists a rare, clear snapshot of how continents deform from the inside out. To date the lava, the team used microscopic zircon crystals trapped inside it. These crystals work like natural stopwatches. They trap helium created by radioactive decay, and by measuring that helium, scientists can tell when the lava erupted and cooled. When they combine that with satellite images and remote sensing, the scientists managed to see Earth's slow-motion movements. The Tuzgolu Fault stretches more than 120 miles and is so massive that you can spot it from space. For years, scientists assumed it behaved like many of Turkey's dangerous faults, where land slides sideways past itself. But this new research flipped that idea on its head. The fault isn't sliding, it's slowly ripping open. The land on either side moves away from each other at less than an inch per year. That sounds tiny, but then again, over thousands or millions of years, that motion adds up to continents literally thinning and breaking. And since the fault sits where three massive tectonic plates meet, this matters way beyond Turkey. All this once again reminds us that continents don't just collide or slide. Sometimes they stretch until they snap. And places that look calm on the surface might already be under invisible strain, inch by inch, year after year, rewriting the map long before anyone feels the shake.
For the last few decades, Earth has had an interesting coincidence. The northern and southern hemispheres have reflected almost the same exact amount of sunlight back into space, but new data from NASA shows that this symmetry is collapsing. The planet is becoming lopsided in a way we haven't measured before. Why is this happening? And will it change the weather we rely on? Well, let's talk about that. If you tear the map in half at the equator, you get two drastically different pieces. The northern hemisphere is the crowded side, having around 68% of Earth's landmass. It has massive continents of North America, Europe, and Asia, the sands of the Sahara, and the snows of the Himalayas. The southern hemisphere is the complete opposite. It is a water world. Aside from Antarctica and a slice of South America, it is almost entirely a deep, dark ocean. In fact, there's a spot in the South Pacific where you can travel for thousands of miles without hitting a single patch of dirt. This area is home to the Oceanic pole of inaccessibility, better known as Point Nemo. It's so remote that if you sailed there, the nearest humans wouldn't be in Chile or New Zealand. They'd often be the astronauts on the International Space Station passing overhead. It's one of the emptiest places on Earth, surrounded by thousands of miles of open ocean. Now, when sunlight travels 93 million miles and hits Earth, two things can happen. It either bounces off the planet and escapes to space, or it gets absorbed. That's because of the phenomenon called albedo. It works exactly like your wardrobe on a scorching day. Lighter surfaces act like mirrors, bouncing the sun away to keep you cool. Darker surfaces are like sponges. They soak up that energy and turn it into heat. Now, humans have actually figured this out on a smaller scale. If you didn't know, many traditional houses on the Greek islands are painted bright white. It's like a form of ancient air conditioning. The white paint reflects the intense Mediterranean sun and helps keep the inside cool. Cities are now trying a similar trick. Places like Los Angeles have spent millions of dollars coating black asphalt streets with a special gray surface to boost the city's albedo. By making the ground a lighter color, street surfaces can cool by about 15 degrees. Now, on a much bigger scale, planetary even, ice, snow, and bright deserts act like mirrors, bouncing back the light, while oceans are the opposite. They soak up the rays and store that energy as heat. So, according to physics, the land-heavy north should reflect more sunlight. The ocean-heavy south should absorb more. Meanwhile, when looking at Earth from space, one half should look brighter than the other. So for decades, NASA has tracked Earth's energy using a system called CERES, short for Clouds and the Earth's Radiant Energy System. These satellites measure how much sunlight arrives and how much leaves. This is how we learn that Earth is cheating around the albedo rule. Now think of Earth's atmosphere as a giant planetary mixer, constantly pushing heat between the north and south to keep it from piling up in one place. According to the latest data, that mixer is starting to fall behind. When scientists looked closely at the CERES data, they saw a clear split forming between the hemispheres. The northern hemisphere is now holding onto more of the sun's energy than the southern hemisphere. Specifically, the north is gaining about 0.3 watts per square foot per decade more solar energy than the south. Yep, that sounds microscopic, but multiply that by every square foot of the Earth's surface, and you have a massive engine of heat that could make the weather unpredictable. Now, you'd expect clouds to push back by reflecting more heat to space. But the data shows that the response hasn't been strong enough, so the extra energy keeps piling up in the northern hemisphere. Now, this is a big deal because heat is what makes the weather move. Hot air rises and pushes wind and storms around the globe. If one side of the planet creates more pressure than the other, those wind patterns have to shift. So it's not just that the weather is getting hotter, it's that it physically moves to new places. You've probably heard of the geographic equator, the invisible line running around the middle of the planet. But there is another equator related to weather. It's called the thermal equator. Think of this as a giant collision zone. Imagine pointing two powerful fans at each other. Where the airstreams meet, the air often gets forced upward, building what could look like a moving wall of rain. Scientists call this zone the Intertropical Convergence Zone, or ITCZ. It marks the planet's thermal equator. Sailors had a better name and knew it as the doldrums. They knew it as a zone where winds cancel each other out. Pirates in the 1700s were terrified of it. You could get stuck there for weeks, just floating, waiting for your drinking water to run out. The system acts like a planetary thermostat. It likes to hang out where the heat is. For most of human history, it stayed right in the middle. But if this imbalance keeps growing, it could nudge the thermal equator north over time. Now, you might be thinking, so what if the rain belt shifts a few hundred miles? Well, history gives us a pretty striking example. About 6,000 years ago, this rain belt sat farther north than it does today. At the time, much of what we now call the Sahara wasn't desert at all. It supported lakes, grasslands, wildlife like hippos and giraffes, and thriving human communities. Rock art from the region even shows boats and swimming scenes. As Earth's orbit slowly changed, the rain belt migrated south. Over time, rainfall faded, lakes dried up, and the landscape transformed into the Sahara we know today. The trigger was different, but the mechanism was the same. When the planet's energy balance shifts, the thermal equator moves, and the rain moves with it. This is a huge deal because rain is incredibly important for food production. It waters the regions that grow our coffee, our chocolate, not our chocolate, yep, and the crops that billions of people eat. If that belt chases the heat and moves north, the rain goes with it. The jungles in the south could dry out, while cities in the north would get hit with floods they were never built to handle. But the air is only half the story. Down at lower elevations, the extra heat triggers a chain reaction. Remember the t-shirt analogy? Much of the northern hemisphere depends on bright snow and sea ice to reflect sunlight away. But as temperatures rise, that low-altitude ice melts. When the white surface disappears, it exposes darker ocean water or bare ground underneath. This creates what scientists call a feedback loop. As the ice melts, it reveals the darker ocean or land underneath, and that dark ground absorbs more heat, which can cause even more ice to melt. It's a cycle that could make it progressively harder for the region to cool itself down naturally. Meanwhile, the oceans take their time responding. Global currents act like a giant conveyor belt, moving warm water around the globe to balance energy. But this system is delicate. It only works when the water's temperature and saltiness are just right. When the north hoards too much heat, it throws the currents off. And if the belt slows or reroutes, the effects don't hit overnight. They unfold gradually over decades or even centuries. But finally, is this just a temporary glitch? Or is the Earth settling into a brand new pattern? Right now, scientists can't tell for sure. Maybe the clouds will finally show up and fix the balance. Maybe the oceans will move the heat around and save the day. But if the North keeps gaining an energy advantage, the weather maps we rely on might change for decades or centuries. If that's the case, many places will have to rethink their daily life. Those not used to rain would suddenly feel cheated, while the value of raincoats, umbrellas, and white t-shirts skyrockets.
We've all thought about rewinding time, whether to fix that cringeworthy mistake or a sneak peek at next week's sports scores. But let's be real, those thoughts fade. For most of us, time travel is just a fun movie idea. But for astrophysicists, time travel isn't just sci-fi. It's a serious puzzle hidden in the fabric of space-time. And now, new models suggest the universe might just allow time to bend in ways that didn't seem possible. Humans were intrigued with manipulating time long before complex scientific models. In an ancient Hindu story, a king visits the heavens for minutes and returns centuries later. In a Japanese legend, a fisherman spends days in an underwater palace and comes back to find generations have passed. These are some of the myths that hint that time doesn't flow the same everywhere. And time traveling as a concept didn't just pop up from regret or curiosity, it also came from watching space. Time feels like one constant in our lives. It's always moving forward like a river. It flows forward and it's predictable. But when we zoom out, way outside of our planet, it's a different story. To physicists, time bends, stretches, and slows down depending on how fast you move or how strong the pull of gravity is. And that's not just a theory, it's measurable, proven, and built into the technology we use every day. For example, astronauts on the ISS orbit Earth at 17,000 miles per hour. And their clocks tick just a tiny bit more slowly than ours. It's only milliseconds, but technically, they've aged less. You can see this effect in your everyday GPS as well. Satellites up there feel less gravity, so their clocks tick a bit faster. Imagine playing a racing game where your car and your controller are a bit out of sync. That's why GPS needs constant tweaks, or else your phone would think you are miles away. Gravity also messes with time. Scientists proved it using two atomic clocks. Atomic clocks are like the ultimate devices that measure time. They don't tick with gears or crystals, they tick with atoms, the universe's own metronomes. One clock was on a skyscraper roof, the other closer to the ground. The lower one, feeling stronger gravity, ticked just a tad more slowly. The difference was tiny, but it proved that even height can tweak time. Now picture being near a black hole where minutes could equal years elsewhere. This might help you get those mind-bending scenes from Interstellar. So yes, time bends, and scientists know this. And the challenge now is learning how to do it on purpose. Einstein's work proved that time could move differently for different observers. The faster you move, the more slowly time passes for you. This phenomenon is called time dilation. Think of Marvel's comic Flash. He runs incredibly fast, but he doesn't really slow the world down. His own clock runs more slowly, so to him, everything else looks frozen. If you could reach the speed of light, your time would almost stop entirely, while the rest of the universe would keep racing ahead. For decades, physicists believed that was the only path to real time travel. But the Flash is a superhero, and Einstein proved that nothing with mass could reach that speed. The faster you go, the heavier you become, and the more energy it takes to keep accelerating. To actually reach light speed, you'd need infinite energy, because your mass would become infinite too. Since infinite energy doesn't exist in the universe, it's physically impossible. That's why physicists started asking questions like, if time can stretch and bend, could it also fold? In 1994, physicist Miguel Alcubierre posed a question. Could Einstein's math let us travel faster than light, not by breaking the rules, but by bending space itself? His answer was, maybe. He imagined a warp bubble, a region of space surrounding the ship that moves with it, carrying it along like a cosmic conveyor belt. In this bubble, the spaceship itself doesn't move. The space in front shrinks, the space behind stretches, and the ship rides the wave forward like a surfer gliding on a moving sea. Inside the bubble, the ship feels no motion. It's sitting still, but the bubble carries it across huge distances. And because the ship isn't moving through space faster than light, it doesn't break Einstein's rules. The universe itself does the moving. That hypothetical bubble would need a special kind of energy to bend space-time this way. Originally, Alcubierre's equations required negative energy or exotic matter, a substance that's never been found in usable amounts. Early estimates said we'd need more energy than Jupiter could provide. For years, scientists have wondered if the universe could allow something like a cosmic shortcut without breaking the known rules of physics. While nothing practical has been found yet, theorists have explored models that closed time-like curves, loops in spacetime that bend back on themselves. Here's how it works. Imagine spacetime as a giant sheet. Normally, moving across it takes time, like walking across a field. But a closed time-like curve is like drawing a circle on that sheet. If you walk along it, you could eventually end up back where you started. In spacetime terms, the start and end could be different moments in time. So instead of just moving through space, you're following a path that loops through time, a theoretical shortcut to the past. This isn't pressing a button to hang out with your younger self, it's more like a time detour, a loop in the universe that could let something trace its way back to the past, all without breaking the speed of light. Einstein's math already lets spacetime do gymnastics near spinning black holes, twisting like a cosmic corkscrew. Physicists can explore these loops on paper, but creating one in a lab is far beyond our reach. If one day we could turn this math into a real spaceship, a warp bubble wouldn't actually make the ship go faster than light. Well, technically, there would be no speed. Inside the bubble, the ship wouldn't move at all. Instead, it would fold space like a piece of paper, bringing two faraway points together. The ship could get there in minutes while still obeying the cosmic rules. This is how it worked in the famous Star Trek series, and what many movies adopted as a method for space travel. In a hypothetical situation, a warp bubble wouldn't just be for spaceships. You could send a probe, a package, or even a cup of coffee across the galaxy without it actually moving through space. It's pretty cool, because since the bubbles move space around it, everything inside stays totally still relative to the bubble, which means no spills and no weird forces acting on the coffee. However, we are still far away from that point. The challenges we face are pretty massive. We still don't have enough energy, and folding space-time at will is still out of our reach. But for the first time, the math suggests that it's not impossible. What used to seem like pure sci-fi is now popping up in real science journals. These concepts aren't just about whipping up time machines or warp drives. Even if we never pull off a warp drive, figuring out how space-time works is a big deal for understanding reality. For now, it's all theory and simulations, but every experiment pushes the impossible line a little further. Yesterday it was no, today it's maybe. And in science, maybe is where the most exciting things happen. So while we're not ready to build time machines or bubbles across galaxies yet, scientists can now study and test these ideas using real physics, which will lead to new exciting discoveries. That is, unless future Earthlings figure out how to do it maybe 1,000 years from now, so they travel back in time to show us how we can do it ourselves. Which will create a grandfather paradox. Unless someone sends the idea back in time and creates a closed time loop.
Beneath the frozen surface of Uranus's moon, Ariel, something massive may be hiding, an ocean more than 100 miles deep. It's 40 times deeper than the Pacific Ocean, and it's been sealed up under ice for billions of years, waiting to be discovered. So Uranus is this pale blue gas giant way out there, the loner planet that never gets much attention. But recently, scientists turned their telescopes and computer models toward one of Uranus's 29 known moons, Ariel. Compared to its sisters and brothers, Ariel's got quite a unique personality. When the Voyager 2 spacecraft flew by in 1986, it caught some photos showing an oddly smooth surface peppered with craters, fractures, and valleys. Those details might not sound exciting until you realize what they mean. This moon was geologically active, moving, cracking, and reshaping itself like Earth does. That's rare in the outer solar system, where most moons are just frozen popsicles, quietly spinning around their planet. When scientists studied those fractures, technically called grabens, they found something strange. The pattern of these cracks looks exactly like what happens when there's pressure building underneath the surface, like a balloon stretching before it pops. It's as if something deep inside Ariel was pushing outward, warping, and breaking the crust. The most logical culprit would be a subsurface ocean, which was once warm enough to push against the icy layers above it. An ocean sealed under miles of ice, hidden for billions of years. So, how would something so far from the Sun even have liquid water? Well, Ariel's orbit isn't perfectly circular, but slightly oval, which scientists call eccentric. That means as it circles Uranus, the gravitational pull changes a little each time. The constant tugging stretches and flexes the moon's interior, creates friction, and voila, generates heat. Combine that with natural radioactive decay inside the rocky core, and suddenly you've got enough warmth to melt ice deep below the surface. So Ariel might have been making its own geothermal spa out there in the middle of nowhere. Scientists modeled its interior structure and found that the stress the tidal forces were causing could have kept liquid water stable for millions, maybe even billions of years. Even cooler, or warmer in this case, is that traces of that ocean may still exist. Ariel's icy shell shows features that look recent, geologically speaking. That means the moon hasn't been completely frozen for all eternity. Beneath those fractures, there could still be small pockets or thin layers of liquid water. And this brings up the most exciting part. Water means potential life. Every time scientists find signs of liquid water somewhere in the solar system, they start whispering that question we all secretly love. Could something live there? Sure, Ariel's no tropical resort, but remember, on Earth, we've found microbes thriving near hydrothermal vents at the bottom of our oceans, living off chemicals, not sunlight. If Ariel once had similar vents pumping heat and minerals into its ocean, it could have easily hosted its own microscopic residence. And if there was an ocean there once, it could still have salt in its interior. Scientists believe salts and ammonia could act like antifreeze, keeping the water liquid longer. So even though the surface temperatures drop to minus 351 degrees Fahrenheit, the inside could stay cozy enough for water to remain unfrozen. Now, before you start packing for Uranus, let's remember this is a moon orbiting a gas giant that's about 1.8 billion miles away from us. Visiting it isn't as simple as booking a plane ticket. Voyager 2 is the only spacecraft that's ever gotten even close, and that was almost 40 years ago. We have better photos of Mars's sand dunes than we do of most Uranian moons. So, for now, scientists rely on clever modeling, telescope data, and a lot of patience. Still, this discovery is big. For decades, we've looked at moons like Jupiter's Europa or Saturn's Enceladus as the best representatives of the ocean world category. They're icy, they have subsurface oceans, and scientists have actually detected water plumes jetting into space from them. But now Ariel joins the club. If we ever send another mission to Uranus, Ariel would be a prime target for exploration. Now, another destination worth checking out is Saturn's moon, Mimas. Scientists have always thought it was just a frozen rock ball, but it might be hiding a whole ocean underneath its surface, and a future spacecraft could find it. Researchers have been mapping how thick the moon's icy crust is, and those maps help them figure out how old this ocean could be and where the ice is thinnest. That's the jackpot spot for future missions to check for liquid water. Mimas doesn't look like a typical ocean world. When you look at Europa or Enceladus, you can literally see the cracks and crevices in their icy shells. Mimas looks smooth and quiet, almost like a cue ball in space. The craters look permanent, carved in rock rather than ice. Nothing about it screams ocean world. But a few years ago, data from NASA's Cassini spacecraft started telling us otherwise. Cassini, the probe that gave us our best tour of Saturn and its moons, kept sending back info that didn't quite make sense unless Mimas had liquid water under all that ice. The more Cassini's data rolled in, the more it looked like there might be a newborn ocean hiding under 12 to 19 miles of solid ice. Scientists used models originally made for Europa to figure out how heat moves through Mimas's icy shell. They wanted to know how thick it was, how much heat it could trap, and whether it could melt ice below. And they found that once melting starts on Mimas, it doesn't stop. It accelerates, and really quickly. All that melting ties back to Mimas's orbit. The Moon doesn't orbit Saturn in a perfect circle. Its path gets a little stretched. That oval shape means the Moon gets pulled and squeezed by Saturn's gravity as it orbits. The same way the Moon's gravity gives us tides here on Earth, Saturn's gravity tugs on Mimas. But instead of water tides, it's flexing solid ice. And that flexing creates heat. So, at some point, something kicked Mimas into a slightly weirder orbit, maybe a collision or a gravitational nudge from another moon. The inside of Mimas heated up, melted some of its ice, and created an ocean under the surface. But then, gravity slowly started to pull Mimas's orbit back into a circle again. When it does that, the heating will stop, and eventually, the ocean will freeze all over again. So basically, Mimas is in its warm ocean-having phase right now. Computer models show that the orbital change probably happened just 10 to 15 million years ago. That's nothing in space-time. It also turned out that the heat on Mimas doesn't move in a simple straight line. It kind of loops and twists, depending on how thick the ice is. which means finding this ocean won't be easy, but it's not impossible. Studying possible ocean worlds, and the ones of which we already know for sure, like Europa, Enceladus, Titan, and Callisto, is crucially important for us down here on Earth. Every time humans find liquid water somewhere new, we're basically discovering another version of the one thing that made us possible. Earth's oceans gave birth to everything alive, including us humans. When scientists learn how Europa's or Enceladus's oceans stay liquid without sunlight, they learn something about Earth's deep sea vents, about heat and balance. When they model Titan's chemistry, they're basically looking at what Earth might have been like before life began. So maybe life isn't that rare, and one day a probe will dip into the icy ocean of Europa with NASA's Europa Clipper, or scoop up water from Enceladus's geysers and find something, even a single living cell. And when that happens, it'll rewrite everything we think we know about life. It'll also remind us we're not the center of the story, but just one chapter in a universe full of water. Now, forget about the Kraken and monsters from the deep. I know, it's hard, but try. And you can forget about the Bermuda Triangle and other marine anomalies. They are nothing compared to rogue waves, giant walls of water that suddenly appear and just as suddenly disappear on the sea surface. The destructive power of this phenomenon remained a mystery to humankind for a long time, but it appears that scientists have solved this secret. A rogue wave is a wave that exceeds at least twice all the surrounding waves. If you imagine the world ocean like a video game, then ordinary waves are your opponents. But the rogue one is a super boss. For centuries, hundreds and thousands of ships have gone missing during their voyages. People have made up a lot of legends about what was the cause of marine disasters. Sea monsters, underwater anomalies, mermaids? But today, scientists are increasingly inclined to believe that rogue waves are the main cause of unusual shipwrecks and missing ships. Some believe sailor stories about anomaly waves, while others didn't. But no one could prove their existence. However, everything changed in 1995, when a giant wall of water 85 feet high collapsed on an oil production platform off the coast of Norway. The waves around this monster were 39 feet high. In other words, the monster wave was about the size of a 9-story building, and the neighboring ones measured about 4 floors high. The oil platform wasn't destroyed, but the wave showed it could cause considerable damage to any buildings. Immediately after that, people began to study the phenomenon of rogue waves. However, in the beginning, instead of answers, scientists got even more questions. So, what's so mysterious about this phenomenon? We know how ordinary waves work. What's the problem with finding out the nature of rogue ones? Well, in fact, the difference between them is huge. Ordinary coastal waves are very predictable. They form because of the wind and the uneven landscape of the seabed. Depending on the depth, terrain, distance to the shore, and wind strength, the size and speed of the wave increase. These waves are safe. If they're not big, you can surf. If they are big, then you'll see them in advance and run out of the water, like me. Rogue ones, unfortunately, are almost unpredictable. They can appear suddenly, even during a calm sea. They appear not only on the coastline, but also in the open ocean, like a high-water cliff. The conditions for the appearance of these monsters are very chaotic. When several waves combine their energy into one, it creates a rogue wave. But this process cannot be predetermined or predicted. How is this energy formed? How is it released? And how much of this energy is needed? The questions are too complicated. Now, to try to figure it out, you can place a special buoy with sensors that scan wave data in the water. Then, you need to wait for the rogue wave to appear. And you don't know if it's going to happen or not. Fortunately, it happened off the coast of Vancouver Island. This monster, which was named the Ucluelet wave, was 3 times the size of the surrounding waves and had a height of 58 feet. Proportionately, it was one of the most gigantic rogue waves ever recorded. And do you think that buoy with sensors help to determine the nature of rogue waves? Of course not. It just showed the wave's data. In order to solve the mystery, a group of scientists from the University of Melbourne went to Antarctica, and this time they managed to find something. They brought the most modern equipment for studying weather conditions in water. They installed powerful stereo cameras on the icebreaker SA Augulus II and obtained three-dimensional images of the ocean surface. Now, observations showed that the formation of rogue waves began when small waves were most susceptible to wind. That is, waves of varied sizes and directions meet the wind, which makes several small waves combine with one large one. It grows faster using this received energy. This is not just a combination of waves, but also their physical effect on one another. Scientists call this nonlinear effects. To get closer to the solution, the scientists also used the fourth-order Stokes theory, which speaks about more complex interactions of waves and their energy accumulation. The theory didn't help much, but it made the whole study more strange. Scientists realized that small waves fed off one another. Then some waves became bigger than the rest and took away all the energy. This process is called modulation instability, and it explains why rogue waves appear so suddenly, as if out of nowhere. Still, scientists admit that even this information isn't enough for them to fully explain these giant waves. Now, long story short, oops, too late, the wind pushes younger waves together, causing them to grow higher and increasing their speed. One wave steals the energy from the rest, and boom! A giant rogue wave appears, looking disproportionately huge compared to the others. It hits a boat, an oil rig, or the surface of the ocean and spills out all that energy. And that's it, silence again. The existence of such a phenomenon has convinced scientists that rogue waves are the cause of many shipwrecks at sea. Now, seriously, think for yourself. When a ship gets into a storm, the captain reports it by radio and makes records in the logbook. But when a ship suddenly disappears from radar without any warnings about harsh weather, then it might have met a giant rogue wave. They're not tied to any particular location. They are sudden and unpredictable, and this makes them some of the greatest dangers in the ocean. So, what do we do now? How can ships, beaches, and oil production stations be protected? How to predict the appearance of a wave? Well, the answer is crest-trough correlation. It sounds incredibly difficult, but it's actually simple. The highest part of the wave is the crest. The lowest part of the wave is the trough. The idea is to measure how closely the ridges relate to the troughs. With strong correlation, waves form in dense groups. There are several regular waves and one or two large ones in the center. These conditions are ideal for the appearance of a rogue wave. Now, it seems obvious that scientists should use some instruments to measure the troughs and crests on the waves. It seems quite complicated, but in fact, these crest-to-trough correlations can be studied by watching the weather and currents. Scientists hope that they'll be able to predict the appearance of rogue waves using the same systems they need to predict the weather. So, you can take a breath. It seems we're safe. Or not. Given how the weather of our planet is changing, scientists expect an increase in wave height in the North Pacific Ocean. This will contribute to the appearance of giant rogue waves, even bigger than the ones people observed off the coast of Norway. How much bigger? 1.5 times? 2 and 3 times? Well, you better sit down. Scientists conducted experimental studies and found out that these waves can get 4 times larger than previously thought. Could the 85-foot-high wave recorded in 1995 be 4 times taller? It's hard to believe, but let's just imagine it theoretically. A rogue wave with a height of 340 feet may appear in the middle of a storm. This is more than the height of the Statue of Liberty from the pedestal to the tip of the torch. Such a giant wave can pull any ship underwater in a second and easily destroy an oil station. It can throw the Kraken or Megalodon out of the ocean like a stuffed toy. But how is it different from a tsunami? Well, a tsunami is born during seismic activity at the seabed. Such a wave grows, gains speed, and then crashes onto the shore. It's predictable, and you can spot it from afar. So let's hope that scientists will be able to predict the appearance of rogue waves in advance and warn ships not to sail into the risk zone. Ordinary people who live in coastal towns and relax on the beach are also at risk. In the future, they'll have to look not only at the weather forecast, but also at the risk of giant waves.
In the near future, humans extract ancient DNA from a long-extinct creature. They patch up the missing pieces with genes from a modern-day animal. Then, in a high-tech lab, they bring the species back to life. Sounds familiar? Well, yes, that's actually the plot of the original Jurassic Park. But the thing is, we're now living in the timeline where researchers are doing exactly that. Although this time, the star of the show isn't a raptor or a T-Rex. Believe it or not, scientists at Colossal Biosciences want to bring back the giant moa. Think of it as an ostrich, only twice as tall and way bulkier. It was a massive flightless bird that went extinct almost 600 years ago. The moa once roamed the forests of New Zealand, towering up to 12 feet tall with its neck stretched. This makes it the tallest bird to ever walk the planet. It weighed almost 500 pounds, but funny enough, that doesn't make it the heaviest bird that ever lived. That crown goes to Madagascar's elephant bird, but still, 500 pounds of bird is not something you want running at you in the woods. The giant moa didn't have wings or a beak built for battle, but it didn't need them. For thousands of years, it lived in peace because it had no natural predators, literally being the top bird. Well, almost. The only thing that could take down a moa was the Haast's eagle, a giant bird of prey with a 10-foot wingspan and claws like steak knives. That was the balance of nature, until people arrived. Around the 13th century, the Maori settled in New Zealand, and as humans do, they adapted quickly. The moa, big and slow as it was, became a crucial and probably delicious food source. Within just a few generations, the moa was gone, and not long after, so was the Haast's eagle. No more moa meant no more meals. It's just how nature and survival work. The Maori were skilled hunters, making a life in a new land. But their arrival marked a turning point in New Zealand's ecosystem, one we're still talking about today. The moa wasn't just big, it played a huge part in keeping forests healthy. Now, 600 years later, scientists want to recreate it using cutting-edge technology and ancient clues. But why go through all this effort to resurrect a bird that's been gone so long? Well, according to Colossal Biosciences, the same company behind those gene-edited direwolf cubs that we talked about before, it's not just about the wow factor. They say moas helped shape the landscape itself. In New Zealand, moas helped control vegetation and spread native plant seeds. They kept forests from becoming overgrown and unbalanced. Without them, some plants lost their main seed carriers, and invasive shrubs started to take over areas once kept in check. So the idea is, if we can't rewind the clock, maybe we can reboot the system. Introduce an animal that fills the same job that can help restore what's missing. Okay, but how do you bring back an extinct species? And is that even possible? Well, sort of. But not in the sci-fi clone a complete dinosaur way like in a movie. The original moa has been gone for centuries, and its DNA is damaged, degraded, and full of holes. So instead of making a perfect copy, researchers are going to remix, so to speak. They'll take whatever usable moa DNA they can find and patch the gaps using genes from its living relative, probably the emu. With a tool called CRISPR, which is like a Photoshop for genomes, they'll stitch it all together, tweak the embryo, and grow it in a lab. If all goes well, the result will be something that looks, walks, and stomps like a moa, but not exactly a genetic twin. It won't be a clone, and it definitely won't be 100% authentic. However, Colossal Biosciences says that's fine. If it behaves like a moa and fills the same job in the ecosystem, that's mission accomplished. So no, we're not recreating the past. Not literally. We're building something new that plays the same role. But here is where it gets interesting. Colossal Biosciences seems to be just getting started. They've got an entire extinction comeback roadmap in place. In addition to the giant moa, the company is also working on reviving the woolly mammoth, the dodo, and the thylacine, also known as the Tasmanian tiger. Each one vanished under different circumstances, but the goal is the same: to create a modern version that can fill the ecological gaps those animals left behind. Woolly mammoths were Ice Age elephants. They were befriending ground sloths and shaking the Arctic ground with each step, knocking down trees and flattening snow. During the Ice Age, this region wasn't the frozen wasteland we know today. It was called the Mammoth Steppe, a dry, windy grassland stretching from Spain to Siberia to Alaska, filled with cold, hardy grasses and scattered shrubs. Mammoths helped keep it that way. However, some scientists think that their disappearance may have turned open ecosystems into soggy, carbon-trapping wetlands. So now, the idea is to mix mammoth DNA with Asian elephants to create a fuzzy, cold-loving hybrid that could help the Arctic stay grassy instead of swampy. Maybe even help slow down climate change by keeping the permafrost frozen a little longer. The dodo bird is probably the most famous extinct animal in history. It lived on the island of Mauritius, where it ate fruit and helped spread seeds across the forest. After European sailors arrived, the number of dodos slowly dwindled. It disappeared in the late 1600s, less than a century after it was first discovered, and some scientists believe that its absence had lasting effects on the island's ecosystem. One example would be the Tambalakoke tree, also known as the dodo tree, which might have depended on the dodo to help its seeds sprout. The theory has been debated, but it's safe to say that the dodo had a part in keeping the island's plant life balanced. Now, Colossal is aiming to reintroduce a bird that's similar to the dodo, hoping it can help those forests regrow as well. And then there's the thylacine, my favorite. It's part wolf, part kangaroo, with tiger-like stripes. Despite these strange features, it was a top predator and helped control prey populations in its habitat. But after being blamed for attacks on livestock, it was hunted to extinction. Researchers believe a new thylacine could rebalance nature where things have gone out of hand. So yeah, the moa might be the headline this time, but it's just one project on a much longer to-do list. However, this is where the big debate begins, because not everyone's on board with this whole bring back a beast plan. While scientists dream of second chances, plenty of people still have big questions. For example, are we actually helping the environment or just poking it with our really expensive science stick? These new animals aren't exact copies. They're mashups. Close enough maybe, but not the originals. Also, ecosystems aren't machines where we can just swap out a part and expect them to work the same. There's also the wildcard factor. A lab-made moa might not act like the ancient one. It could munch the wrong plants or throw off the balance by outcompeting something that wasn't even around the last time it existed. Some experts worry that tossing new species into today's ecosystem could backfire. After all, the world they're coming back to? It's different. And in some cases, their old homes don't even exist anymore. There's also a deeper concern: the message this sends about extinction. If people believe we can just bring things back, will they take conservation any less seriously? Will protecting endangered species feel less urgent if extinction stops being permanent? So while the science behind all this is undeniably impressive, the ethical questions aren't going away. Should we be reviving species, or should we be doing more to protect the ones that are still here? If both options are true, how do we do so successfully? Whether it's mammoths, moas, or dodos, one thing's clear: we're not just studying nature anymore. We have the power to rewrite it. And like Uncle Ben said, with great power comes great responsibility. Let me know what you think. And as always, stay on the bright side. A huge invisible danger zone is hanging above Earth, messing with satellites, zapping electronics, and giving astronauts a headache. Scientists call it the South Atlantic Anomaly, and it's kind of like the Bermuda Triangle of space, because weird stuff happens there and nobody fully understands why. Want to know more about this thing? Well, Earth has a magnetic field that protects us from dangerous radiation from the sun. We'll talk about it later. And over one spot on the planet, right above the South Atlantic Ocean, that shield gets weirdly weak. It stretches over South America and parts of Africa, creating a sort of magnetic soft spot. That weak spot is bad news for anything flying up there. When satellites travel through it, their systems can freak out. Computers freeze, data gets scrambled, and sometimes entire instruments shut down. Basically, the space version of your phone glitching out right when you need it most. Astronauts have to be extra careful in this region too. When the International Space Station passes through the anomaly, radiation levels spike. It's not enough to fry anyone, but it's surely not fun. The equipment can take a serious hit. No one knows exactly what's going on yet, but scientists think the SAA might be a clue that Earth's magnetic field is shifting. If that's true, it could mean big changes for the future, for us all. You see, the South Atlantic Anomaly is connected to Earth's molten insides. Deep beneath the surface, the planet's core and mantle are constantly moving, flowing, and clashing. The outer core is a swirling ocean of liquid metal, and the mantle above is hot, solid rock. Under Africa, there's nothing to cool things down. The mantle is hotter than usual, which creates certain instability in the magnetic field above. As for South America, there, the Nazca Plate is dragging rock and debris down toward the core. This cools things off and keeps the field more stable. Such a wild temperature difference seems to be fueling the anomaly. According to some sources, it drives it across the Atlantic. The anomaly is slowly drifting westward. The thing is, Earth's magnetic field protects us from dangerous radiation from space, powerful solar winds, and wild swings in temperature, and keeps our atmosphere in check. But over millions of years, the magnetic poles have flipped. When it happens, north becomes south, south becomes north, and during those flips, the field can weaken. And some scientists thought the South Atlantic Anomaly might be a warning sign before a full magnetic reversal. It could mean disaster to humans, but we'll talk about it later. The good news is, these flips take over. On average, Earth flips its magnetic poles about 2 times per million years. That means the next reversal could be hundreds of thousands of years away. Nearly 600 million years ago, our planet's shield almost failed, but at that time, it could have been a good thing. Scientists think this near collapse might have triggered a massive evolutionary boost and helped the first complex life forms to evolve. Back then, during a period called the Ediacaran, the magnetic field weakened drastically and stayed that weak for about 26 million years. With less protection, solar radiation removed lighter gases from the atmosphere, leaving oxygen floating freely in the air and oceans. That oxygen helped the first multicellular oxygen-breathing organisms to see the light of day. Those were strange, squishy creatures that hardly resembled animals today. Some were disc-shaped blobs, fronds, or shapeless fans, stretching over 3 feet long. By the way, one of the earliest known animals, Dickinsonia, was among them. It looks kinda pretty, doesn't it? Now, how do we know all this? Thanks to rocks. They're like time capsules. Tiny crystals inside them preserve the power of the magnetic field from hundreds of thousands of years ago. For example, certain crystals from southern Brazil revealed that 591 million years ago, Earth's magnetic field was 30 times weaker than it is now. And rocks from South Africa dating back 2 billion years showed that the field was at full strength back then. Now, let's explore a bit. Deep beneath our feet, there's Earth's inner core. We're used to thinking about it as a perfect solid ball. but new research suggests it might be changing shape. Over the past 20 years, parts of the inner core may have bulged or dipped by more than 300 feet. That's like a skyscraper popping up or sinking deep underground inside the planet. This core spins independently from the outer liquid core, which creates the magnetic field that shields us from dangerous solar radiation. The magnetosphere is non-negotiable. Without it, Earth would lose its atmosphere over time. Water would vanish, and life as we know it wouldn't survive. It basically keeps the planet alive. Without it, Earth could turn into a barren Mars, which lost its magnetic field billions of years ago, and along with it, almost all its atmosphere. So why is our planet's inner core deforming? It seems to happen where the solid inner core meets the super hot liquid outer core. The molten metal flows around it, and combined with the tug of an uneven gravity field, likely warps its edges. Scientists can't drill down to the core to check this theory. It's 3,200 miles below the surface. But they can track seismic waves from earthquakes as they ripple through Earth. They measure how these shock waves bend, slow down, or speed up, and it can help figure out what the inner core is made of and how it moves. That's probably how they know that the solid inner core is slowly growing, freezing layer by layer of the liquid outer core. But don't worry, it'll take billions of years to fully solidify. By that point, life on Earth would probably already be gone anyway. The sun's gonna swallow our planet long before the inner core stops moving. But let's get back to the topic that, I bet, worries you most. What if Earth's magnetic field just vanished one day? Well, the planet would be hit by a storm of charged particles from the sun. Satellites would start glitching and power grids would go down. We would get zapped with higher levels of UV radiation, the kind that can cause all kinds of serious health issues. In short, it wouldn't be instant doom, but life would get a lot trickier. Luckily, now we know that a magnetic field doesn't just vanish overnight, but ours has been slowly weakening for over a century. So what would life on a planet with a super weak magnetic field look like? You would just have to throw away your compass. It wouldn't point north anymore, just towards the nearest patch of strongest magnetism, wherever that may be. The northern and southern lights would go insane, appearing closer to the equator, all because charged solar particles would be able to get through the atmosphere more easily. Satellites would be under constant attack. Solar particles would fry their electronics, mess with memory, and cause what scientists call single event upsets. High-frequency radio signals would also get scrambled, thanks to free electrons in the ionosphere. Over time, the solar wind could even start wearing down the ozone layer, leaving us all more exposed to UV radiation. Now, let's decrease the level of drama. A magnetic field isn't the only thing keeping a planet alive. Mars did lose its magnetic shield about 4 billion years ago, and most of its atmosphere got blown away. But Venus has no global magnetic field, but still has a thick atmosphere. If Earth lost its magnetic field completely, we wouldn't instantly vanish, but life would definitely change, and we would have to get used to these drastic changes. A giant crack, more than 2,000 miles long, is splitting open across Africa. Roads, houses, even schools are getting torn apart. Now, scientists think they've finally figured out what's causing it. An enormous column of scorching hot rock called superplume, rising from deep inside the Earth. And it's slowly pushing the land apart inch by inch. This isn't a small shift though. The continent is breaking in two, and the clue to what's going on could be hidden thousands of miles away in Hawaii. And why does the United States suddenly have a role in all this? Hang on, we'll get there. First, it's important to know this isn't new information. Africa has been slowly splitting for about 25 million years. This is happening in a region called the East African Rift System. It stretches thousands of miles from Ethiopia down to Mozambique and is the largest active continental rift system on the planet. And by that, I mean places where the Earth's crust is being stretched and pulled apart, causing faults, earthquakes, and volcanic eruptions. Scary stuff to say the least. Back in 2018, for example, a massive crack appeared near a small town just west of Kenya's capital, Nairobi. In some spots, it was about 65 feet wide. That's almost the length of 2 school buses parked one after the other. The whole thing was terrifying. It happened fast and left a trail of destruction. Roads were cut off, farms torn apart. People were on edge as the ground opened up beneath their feet. And I mean that quite literally. One man watched the crack rip straight through his home. He barely had time to grab a few of his belongings before his entire house collapsed. Sounds terrifying, right? Since it happened in the East African Rift region, panic spread fast. The media was all over it, claiming it was proof that Africa is splitting apart. People standing near the crack thought, oh boy, it's already happening. And many still believe that today. But that's not actually the case. At least not with that particular crack. Because after the initial panic, videos and photos of it revealed clues that it wasn't related to tectonic plate movement. First clue, the 2 sides of the crack didn't match. Like trying to fit the wrong puzzle pieces together. They simply didn't line up. Second clue, the gap wasn't one continuous line. There was some kind of soil bridges in between. All this showed it was sudden erosion. I mean, some specialists believe the crack had once been filled with volcanic ash from nearby Mount Longonot. But then the region was hit with heavy rains. When water soaked through the soil, it washed the ash away, leaving the gap exposed. Problem solved. Even after the truth came out, it was too late. This event brought the whole Africa is splitting talk back. And here's the thing. Even though that crack had nothing to do with it, make no mistake, Africa is breaking apart. That's because the continent sits between 2 tectonic plates, the Somali plate in the east and the Nubian plate in the west. The problem is they're moving away from each other, and as they drift apart, the gap in the East African rift keeps getting wider. Eventually, the Somali plate could split completely from the Nubian plate, creating an entirely new landmass, something on the scale of Madagascar or even New Zealand. You don't have to worry though. This process is super slow. So slow that none of us will see it finished. Experts say the continent is moving apart by about 0.3 inches a year in some places. To give you an idea, that's less than the length of your fingernail. So we can say this split will take millions of years, which is good news for the people living there. But that doesn't mean they won't feel the effects of this slow break. In fact, they're already happening. Take Ethiopia's Afar region, for example. Back in 2005, this area showed just how unpredictable the rift can be. In a short period, 420 earthquakes hit the area, opening up a massive fissure. What usually takes centuries happened in just a few days, completely challenging what scientists thought they knew about the speed of geological changes. Back then, the crack stretched for more than 35 miles, and life around it is still far from easy. Recent earthquakes destroyed much of the local infrastructure. 37 schools were damaged, leaving 5,000 students without classrooms. And that was just one part of the damage. As the tectonic plates keep moving apart, water will eventually flood into this region, creating a brand new ocean, according to some predictions. Countries like Zambia and Uganda, which are landlocked today, could one day have a coastline. That could be great news for them, as it might open up new trade routes and completely reshape their economies. Don't get too excited though. We won't be diving into the waters of this 6th ocean anytime soon. The splitting process will take another 5 to 10 million years. But it's tough to say exactly when, since big seismic events, like earthquakes, could make it all happen faster. So here's what we know. The Somali plate and the Nubian plate are in the middle of a dramatic tectonic breakup, slowly moving apart. Africa is breaking in two. Earth will probably gain a new ocean because of it. But until recently, we didn't know exactly what was triggering all of this. Like, yeah, those tectonic plates are moving, but why? I mean, is this massive geological process being driven by something happening in Earth's mantle? Or could it have a much larger, deeper source? Well, scientists think they may have finally cracked the mystery. They believe the continent is breaking apart because there's a deep mantle superplume, a huge column of hot rock beneath the East African Rift System. Think of it as a massive subterranean hammer pushing upward, pressing against the crust, and slowly cracking it apart. But here's the interesting thing. Scientists reached that conclusion thanks to something that happened in a completely different part of the world, Hawaii. Under this US state, there's also a plume of super hot rock rising from deep inside the planet. It melts the crust above it, and that's what fuels Hawaii's volcanoes. As the Pacific Plate drifts over this plume, molten rock breaks through in new spots, creating volcano after volcano. Over millions of years, that's how the Hawaiian Islands were formed. This Hawaiian plume contains noble gases like helium and neon. And you know where else scientists found those same gases? That's right, beneath the East African Rift System. Bingo! That discovery backed up the theory that a superplume is driving what's happening in Africa. And we call it super because it might be massive. You see, these same gases have been found in volcanic rocks from Kenya all the way down to Malawi. So everything points to the existence of a single superplume that stretches from the Indian Ocean to the Red Sea, not a bunch of several isolated sources. If their data and research are correct, scientists estimate that this superplume beneath Africa likely starts at the core mantle boundary, which is located about 1,800 miles deep inside the Earth. While the East African Rift System's chemical signatures are similar to those found in volcanic rocks in Hawaii, they're not identical. The Hawaiian plume is thought to be a narrow, rising stream of hot mantle, a bit like the movement inside a lava lamp. Africa's plume might be shaped differently, more like a large mass of hot, buoyant material rising from deep within the Earth. As it reaches the surface, this hot material hits the colder, solid outer layer and spreads out, pushing hard enough to crack it open and trigger intense volcanic activity across the region. And if this theory is right, we're watching a slow but unstoppable force that will redraw Africa's map and change the continent forever.
Just when you think space couldn't get any more weirder? Hey, check my grammar. The universe throws a curveball in the form of a giant glowing bubble that's too perfect to be real. Astronomers have spotted something strange drifting through our galaxy. And it's not a rogue planet, which is a space body the size of a planet that doesn't orbit any star. It's not a star itself either. It's not even your average supernova remnant. It's a perfectly round sphere, and scientists are stunned. Astronomers were going through data from a super powerful radio telescope when they spotted something that looked like a perfect round bubble. At first, they thought it was the leftovers from a massive star explosion called a supernova. But the weird part was that the object was too perfect. Normally, such explosions leave behind messy, uneven clouds. And the newly discovered one looked like someone had drawn it with a compass. The scientists named the space bubble teleos, which means perfect in ancient Greek. They've already looked at all the possible explanations, but none of them really make sense yet. This strange space body was discovered thanks to a telescope in Australia called ASCAP. It's been scanning the sky and finding all kinds of weird circular objects. This research was part of a project called the Evolutionary Map of the Universe. Some of the faraway circles, known as ORCs, which is short for odd radio circles, have already puzzled scientists. But this one is different because it's inside our own galaxy. At the same time, even though Teleos is technically closer to us, scientists can't quite figure out how close it is. And that's making it harder to understand where it came from or how it formed. The researchers have taken an even closer look at this strange space bubble and found something super odd. It only gives off a very faint glow and only in radio waves, not in visible light or X-rays. Based on that glow, they figured it's most likely the leftover shell of a massive star explosion called a Type Ia supernova, one of the brightest and most powerful kinds of explosions in the universe. This kind of explosion happens like this. A super-dense dead star called a white dwarf starts stealing material from a nearby star. It keeps sucking in stuff until it just can't handle the weight anymore, then it blows up in a huge burst of energy. Now that part makes sense. But figuring out how far away is this thing? Strangely, it's not so easy. Scientists have run the numbers and ended up with two possible distances for Teleos. Either it's around 7,175 light-years away, or it's much farther, about 25,114 light-years away, give or take. Depending on which distance is right, the size of the bubble could be vastly different. If it's closer, then it's about 46 light-years wide. That would make it a pretty young supernova remnant, maybe less than 1,000 years old. But if it's farther away, then it's a giant 157 light-years across, which could be more than 10,000 years old. So, which one is it? That's where things get tricky. Scientists have models that tell us how these supernova leftovers should behave. And one of the most important things they expect to see is X-rays. But you might remember that Teleos doesn't show any, not a single X-ray in sight. That's the big mystery. How can something that should be glowing with X-rays be totally silent? It just doesn't add up and leaves the scientists very puzzled. Another idea the scientists are considering is that Teleos might not be a regular supernova remnant at all. Instead, it might be the leftovers from a rarer kind of explosion called a Type Lax supernova. And this one? It's extra weird. In a normal Type La supernova, the white dwarf star blows itself to bits. But in a Type Lax supernova, it doesn't get totally destroyed. It kind of survives, turning into a zombie star. Ooh. It's damaged, but it's still around. This would actually explain a lot about how Teleos looks and glows. But in this case, it would have to be much closer to us, only about 3,262 light-years away. That would also make it a lot smaller, about 11 light-years wide. The coolest thing here is that there's actually a star at that distance that could be the zombie star that caused all this. But, and it's a big but, like I have, when scientists use other ways to try and measure how far away Teleos is, none of them agree that it could be this close. So, sadly, this theory hits a bit of a wall. Then there's another strange thing. Teleos' nearly perfect spherical shape. That's not normal. Usually supernova explosions are kind of messy and uneven. The blast might push into clouds of space dust or gas, or parts of the explosion might move faster than others. Eventually, the shell that forms gets all lumpy or starts to break apart. But in this case, the object is almost perfectly round, like a balloon, and that's super rare. The only way something could stay this neat and round is if it exploded in a very empty part of space and expanded smoothly in all directions. That's actually not impossible, just really, really rare. Now, considering its unique, probably unnatural shape, could Teleos be an artificial object? Could it be a Dyson sphere? That's a hypothetical megastructure that could completely surround a star and harvest all of its energy. At first, this idea was supposed to explain how we might detect intelligent extraterrestrial life by spotting the energy they use rather than waiting for them to send us a message. You see, here on Earth, we only receive a tiny bit of the sun's energy. Meanwhile, a whopping 386 billion megawatts are shooting out into space in all directions. Not to waste such a giant amount of energy, a civilization could build a Dyson sphere, or more realistically, a Dyson swarm, loads of solar panels orbiting the star. It would help them capture every bit of that power to run their planet, technology, AI systems, and maybe even space travel across galaxies. To understand just how advanced a Dyson sphere-building species would have to be, scientists use the Kardashev scale. It ranks civilizations by how much energy they can use. Type 1 can use all the energy available on their home planet. Spoiler, we're not even there yet. Type 2 can harness all the energy from their star. That's the Dyson sphere level. Type 3 can use energy from an entire galaxy. Think Dyson spheres around every star and even extracting energy from black holes. Right now, Earth's civilization ranks about Type 0.7449, give or take. That means that we haven't even maxed out the energy available to us on Earth, including fossil fuels, renewables, and nuclear power. We're still taking baby steps on this cosmic scale. Anyway, the problem with the theory that our perfectly shaped object could be a Dyson sphere is that this example of super advanced technology would give off heat. In other words, there would be thermal infrared radiation, and the object would be unusually bright in the infrared. This could be a sign that something artificial is absorbing the star's energy and re-emitting it as heat. But the scientists have found no heat signatures or anything like that when observing Teleos. So, do we have the final answer? Not yet. The scientists have looked at all the existing clues, how bright the thing is, how big it looks, and how far it might be. And none of the possibilities are totally perfect. Each idea has a problem, especially the fact that we're not observing any X-rays, which should be there according to the usual rules. They still think that regular type LA supernova idea is the best bet for now, but they're not 100% sure. There's just not enough proof to say for certain. So, the mystery continues. The team says we'll need more powerful and detailed observations to really figure out what happened here. But in any case, if something like Teleos can exist, what else is out there, waiting to challenge everything we know about the universe?
You're digging in Egypt's famous Saqqara necropolis, also known as the ultimate VIP graveyard for pharaohs, when suddenly you find a giant pink door hiding something no one knew existed. Behind this giant stone door, one that wasn't supposed to open, by the way, you find a lost tomb of Egyptian royalty. Alright, history lovers, it's time to buckle up because archaeologists just pulled off something straight out of an Indiana Jones movie. Let's travel all the way to Saqqara, one of Egypt's most mysterious and treasure-packed ancient sites. The star of the show? The prince you've probably never heard of, Prince Userefre, son of King Userkaf. No one important, just, the founder of Egypt's 5th dynasty. No big deal. But the way his tomb was discovered… It all started with a massive door, made of pink granite, no less. But this isn't just a regular stone slab. This thing is about 14 to 15 feet tall and 4 feet wide. A giraffe could easily walk through it. This door is also definitely heavier than your neighbor's SUV. But here's the twist. It wasn't a real door. It was a false door, a symbolic gateway meant to allow the spirit of the deceased to pass between the world of the living and the afterlife. Normally, that's where the story ends. After all, false doors are common in tombs. But this one was extra special. You see, false doors were usually made out of limestone, which was pretty common and found everywhere in Egypt. To build one out of red or pink granite, people had to bring these rocks from a quarry located 400 miles away. And you can bet this wasn't a cheap trip. According to Egyptologists, this is the first time a false door of this size and material has ever been found in Egypt, making it a totally unique piece of architecture. Aside from being super expensive, this one had a surprise behind it too. When the team of researchers investigated further, they realized that this false door actually hid a real entrance. And what did it lead to? A hidden tomb, packed with statues, relics, and secrets from over 4,000 years ago. The tomb belonged to Prince Userefre, but you can call him Wasar Efra, or Wasar Efra too. Despite being totally erased from history, this fella was no minor noble. The hieroglyphs on the pink granite door listed him as the hereditary prince, governor of Buto, En Nekeb, royal scribe, minister, judge, and priest of chance. Phew! He was like the ancient Egyptian version of Daenerys Targaryen. These inscriptions not only identify his political and religious roles, but also suggest he held significant power in Lower and Upper Egypt, bridging both regions through his titles. One title in particular, the Priest of Seker, links him to the deity of the necropolis, the one with the falcon head. This god was the patron of the living and god of the dead at the same time. So I guess the Forgotten Prince was sort of a big deal, considering that his tomb was placed in such a prestigious location within Saqqara. What's even more mysterious is that Prince Userefre doesn't appear in official king lists or royal family trees, which makes us wonder if he passed away before he could rule, or if his legacy was deliberately erased in one of ancient Egypt's classic political dramas. Some scholars now believe his erasure might be connected with shifting religious or political power struggles during the early 5th dynasty, especially as his father Userkaf was reshaping Egypt's religious order. And speaking of his father, King Userkaf was a total game changer. He wasn't just the founder of the 5th dynasty, he also kicked off a religious revolution by promoting the sun god Ra over older deities. That's right, Userkaf built the very first sun temple at Abu Sir, setting off a dynasty-wide obsession with solar worship. After Userkaf wrapped up his short but revolutionary reign, a whole lineup of pharaohs took the stage. Sahure, Neferirkare, Nusere-Ini, basically the boy band of the 5th dynasty. And these guys were all about two things: building pyramids and making money. They weren't just stacking stones, they were expanding Egypt's influence, opening up trade routes to far-off lands and blinging out their temples like it was nobody's business. Back in the tomb, things got even cooler. There was a beautiful red granite offering table covered with inscriptions detailing ritual foods, like an eternal menu for the afterlife, because they believed the deceased could magically eat this food. Fun fact, it was the funerary priests and their families that actually ate the food. There were also pottery shards, amulets, and painted walls, but the real showstoppers were the statues. And this is exactly where things get weird, in a good way. The team found statues of King Djoser, the guy who built Egypt's first pyramid, his wife, and their 10 daughters, inside Prince Userefre's tomb. Hold up, Djoser lived a few centuries before Userkaf, so what were his statues doing there? Turns out, scientists don't really know. These statues were built during the reign of King Djoser himself and probably belonged to that first ever built pyramid. Experts believe these statues were probably relocated during the 26th dynasty, thousands of years after Djoser, maybe to protect them from destruction, or maybe because they were still venerated. Basically, ancient Egyptians were hoarders, but classy ones. Scientists also know for a fact that some engravings and statues found there were made way later, which means that this tomb probably turned into a deposit for fancy stuff. Or maybe this was just really ancient interior decorating. Anyway, that wasn't all. There was another pink granite entrance on the eastern side of the tomb, with inscriptions linking back to King Neferirkare, another 5th dynasty pharaoh who also tried to build his own pyramid, but failed. And near this second entrance, archaeologists found something never seen before in Saqqara: a set of 13 pink granite statues, all sitting in a row on a high-backed bench, like they were waiting at the DMV of the afterlife. Some had elevated heads, probably representing the prince's wives, while others were missing their heads entirely. One black granite statue was found upside down. Maybe it had taken a tumble sometime during the tomb's long, quiet centuries underground. According to archaeologists, the positioning and head shapes suggest that these statues followed a strict social hierarchy, with the central figures likely representing higher status individuals, while the headless ones might indicate unfinished work or later vandalism. And speaking of black granite statues, another one was found standing proudly inside the tomb. Based on its design and inscriptions, it looks like it was placed there during the 26th dynasty, the same time those Djoser statues were probably moved in. This suggests the tomb didn't just sit abandoned, it was reused, adapted, and maybe even honored by later generations. And by the way, black granite was associated with Osiris, the god of the underworld, during the late period, which means that this statue's presence is a clue that the tomb was a ritual space long after the prince's death. All of this, giant granite doors, surprise statues, reused tombs, adds up to a truly thrilling find. Prince Userefre may not be a household name yet, but his tomb is now one of the most fascinating ever found in Saqqara. It tells a story not just of the Old Kingdom, but of how ancient Egyptians kept connecting to their past, even thousands of years later. So, what does it all mean? Why hide a tomb behind a fake door? Why pack it with statues from different eras? And who exactly was Prince Userefre? These are the kinds of mysteries that keep archaeologists digging and keep the rest of us fascinated. In the end, this discovery isn't just about one tomb, it's about how much is still waiting beneath the sands of Egypt. As more gets uncovered, we're reminded again and again that ancient history isn't gone. It's just sleeping behind massive pink granite doors. Have you ever visited a famous monument and thought, alright, this is boring? While you were up on the Eiffel Tower yawning at the view, another landmark in Paris was pulling off the ultimate plot twist. Hidden in plain sight at Place de la Concorde stands a 3,300-year-old Egyptian obelisk that's been keeping juicy secrets from Pharaoh Ramses II himself. That's right. Ancient secret messages carved in stone have been right under our noses this whole time. Nope, this isn't the next National Treasure movie. This is real life, and it took a real-life Indiana Jones to crack the code. So, let's set the stage. You've probably seen this block of stone before, right? Towering 75 feet high, this massive granite pillar was originally from Luxor, Egypt, and it's been chilling in the heart of Paris since 1836. It's covered in hieroglyphs, and for years, everyone assumed we'd already cracked their code. Mystery solved. Nothing left to see here. Enter Jean-Guillaume Olet-Pelletier, French Egyptologist, cryptology expert, and part-time monument whisperer. Basically, if Indiana Jones traded his whip for reading glasses and binoculars, you'd get this guy. He's got a rather unusual hobby. He strolls up to the obelisk every now and then and casually reads hieroglyphs. For fun. Yes, he can read them fluently. No, we don't know what that says about our own hobbies. Until 2021, experts believe that the inscriptions on the obelisk mainly praise the gods Amun or Amun-Ra, if you're on friendly terms, and Horus, you know, the falcon-headed sky god with those super famous parents Osiris and Isis. But during one of his casual reading sessions, Olet-Pelletier noticed something odd. Some of the hieroglyphs weren't just singing praises to the gods, they were giving directions, literal directions, to the entrance of the temple of Luxor. But wait, it gets even better with a little backstory. Obelisks like this weren't just pretty lawn decorations. They were usually placed at the entrances of major temples, like the Temple of Luxor, where this one originally stood. They symbolize the sun god Ra and were meant to represent a ray of sunlight frozen in stone. Basically, they were giant sacred exclamation points showing off the pharaoh's divine connection and power. Ramses II had two of them set up at Luxor's entrance to honor the gods and, of course, to brag about himself. This one got shipped off to France in the 1830s as a gift from the ruler of Egypt, Muhammad Ali. No, not the boxer. And it's been waiting for someone to take a closer look at it. Moving the obelisk to Paris was no small feat. It weighed over 220 tons and had to be transported on a ship built especially for it, called the Luxor. How original. The whole transportation cost the modern equivalent to $19 million. Interestingly, its twin obelisk still stands in Luxor, which means that researchers can compare both structures to see if the story really matches. This pairing of obelisks was intentional, meant to guide the eye and the spirit towards sacred space. Lucky for us, Jean-Guillaume picked the perfect moment to snoop around. The obelisk was undergoing restoration for the upcoming Olympic Games. Scaffolding was up, giving him rare access to the tippy top of the monument. Armed with binoculars and a ladder, he got eye level with parts of the pillars that most of us can only squint at from street level. And that's when he uncovered the real twist. Turns out, ancient Egyptians didn't just chisel random symbols into stone. They had something way cooler up their sleeves: crypto-hieroglyphs. Those were specialized coded forms of writing used for sacred or elite messages. Basically, ancient VIP-only emojis. While your average temple priest could read standard hieroglyphs, crypto-hieroglyphs were reserved for the pharaoh's inner circle. Today, only 6 people on Earth can read them fluently. And wouldn't you know it, our French friend is one of them. Of course he is. Now, here's where things get wild. Normally, hieroglyphs written on monuments like the obelisk are read top to bottom, right to left. Simple enough. But Jean Guillaume decided to break the rules and read them horizontally instead of vertically. That's when he started spotting weird patterns, phrases, and symbols that had been hiding in plain sight for nearly 200 years. Some of these messages were so cleverly hidden, and you could only understand them if you walked around the obelisk in a certain way. He calls it 3D cryptography. That's right, the obelisk itself is like one giant ancient Rubik's Cube. Depending on the angle you read from, the message could change entirely. Yes, ancient Egypt invented something like the lenticular effect long before Pokemon cards made it cool. Okay, so what in the world does the message say now? Glad you asked. These aren't just random notes from the past. They're political gold. One inscription praises Ramses II as a divine figure who could not be dethroned. Another says the king made offerings to the god Amun, which wasn't just him being nice. This was a big political move. Back then, religion and power were totally intertwined, so showing off your divine connection was like launching a PR campaign, except instead of tweets, they used 200-ton stone monuments. Ramses II wasn't just any ruler, by the way. He reigned for over 60 years and basically pulled off the Beyoncé of pharaonic careers. He won battles, or at least said he did, built cities, temples, and statues of himself all over Egypt, and declared himself a living god. When he ordered these obelisks, he wasn't just creating monuments. He was launching ancient propaganda flyers at priests, nobles, and visiting dignitaries. In fact, Ramses II was so good at self-promotion, he may as well be the original king of rebranding. He claimed victory at the Battle of Kadesh, even though it ended in a stalemate and they had the victory carved into walls and monuments across Egypt. The Luxor obelisk was another way of reinforcing his godlike powers every time someone passed by or read its text. And here's the cherry on top. Some of these inscriptions were positioned just right so they'd be seen by nobles arriving by boat for a festival. That's probably the reason why they can only be read from a certain angle. But if you stood at the base of the obelisk, you wouldn't see much. But from a 45-degree angle standing right in the middle of the Nile, sweet stuff! Imagine pulling up to a religious celebration and seeing giant stone text basically saying, "Hey, Ramses is chosen by the gods, don't forget it." Subtle? Not exactly. Effective? You bet. Some messages even carry double meanings. One line might spell out Ramses II's full royal title. But read it differently and boom! It says he's got eternal life. That's next-level branding. You can almost hear him saying, "Look at me, still trending 3,000 years later." For decades, scholars thought this monument had given up all its secrets, but thanks to new access, modern tools, and some fresh eyeballs, we now know there's still a ton to uncover. Oleg Pelletier's full research hasn't been officially published yet, but the clues he's found are already shaking up what we thought we knew about ancient Egyptian monuments. Of course, not everyone's buying it just yet. Some scholars are skeptical, especially about the idea that boat-riding nobles could actually see those messages clearly. But let's be honest, ancient advertising wasn't easy. Even if your billboard is 75 feet tall, you still need the right angle and the right audience. So the next time you're in Paris staring at the obelisk while sipping your overpriced café au lait, remember, you're not just looking at a fancy paperweight from the 19th century. You're standing in front of an ancient Egyptian PR campaign, a 3D puzzle, and a 3,300-year-old flex from Ramses II himself. And let's be real, if that obelisk had been hiding messages this long, who's to say it's done talking? So grab your magnifying glass, channel your inner Egyptologist, and remember, the real treasure isn't gold or jewels, It's the drama chiseled in stone.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.